Hey, welcome to SkyTour LiveStream. This is Mark D'Antonio. As always, it's a beautiful August 8th, 2020, and tonight we're going to spend some time zipping through clusters and nebulae in Sagittarius, the southern star cloud of Sagittarius, or the northern star cloud, I guess you'd have to put it right. So we're going to have some fun. And I have with me, as always, Daryl Mason. Hey, Daryl, what's happening?
Hi, Mark. Sounds like Northern Prejudice to me.
Yeah, and your volume's a little low right now. I don't know why.
Okay.
So we'll crank that up, if you will.
I did a little bit. Let me know if it's still a problem.
Okay, it's sounding better. And we also have with us Carol Carl. Hey, Carol, how are you?
Well, I'm fine, and so glad to be here.
Awesome. Yeah, Carol is, of course, the host of Behind the Obsidian Curtain, Friday nights at 7 p.m. on kgraradio.com. Very popular show. She has tremendous guests. You got to give it a listen.
I thank you for that.
Of course. I want to say hi to Voodoo Paps is here, Dagger Spells, and Daisy and Zoe. Welcome. Francis Palmer, hello. Terry Groff. And Tara is here, and I see Bob Harless has joined us tonight as well, and Tim F. You guys are great. Hi, Gene Leone. Welcome. Good to see you here again. And Gaia Savellas is here. How are you, man? So good to see you guys here tonight. We're going to have some fun tonight going through all these nebulae and clusters. And, you know, the first thing we got to do, though, is we actually have to go to one that Daryl has asked for, because he asked us last time, and we didn't go there. Just in case you're wondering where we are now, this is the star Antares right here. It is the red star in the southern part of the sky right now. It looks like this, and I'll show you some of the photos. Okay, this is Antares. I took a few just a little while ago just to check it out. Okay, and this is the area around Antares, and we will come back possibly. But what I want to do first is I want to get us over to Messier 7, which I believe isn't that Ptolemy's cluster, Daryl?
Yes, it is.
Yeah, and because Daryl asked for Ptolemy's cluster. Oh, look, I just happen to have it selected. And we're going to go
Well,
there. We're going to go there and check it out. So what we do is, if we go back to our main view, again, just a quick rundown for those that have not been here before. I'll tell you what's going on. Hold on, let me just get us to the right view. There we go. Okay, so up here, this part up there, right up there, that's the telescope control system. This is the control right here that controls north, south, east, and west. This is access to the telescope's computer. This is the focusing section. And down here is the filter wheel section, the area where we actually rotate through these 5 filters all in these big circular 2-inch diameter holes. Have all these different filters in them that will allow us to see different light of the spectrum here for what we're doing. And that's kind of what we're trying to do tonight, is look at these clusters and nebulae in a different spectral light. They really look beautiful. So that's that. Okay, then down here, this is well, let me just keep it all together. Okay, so down here, this is me. Hi, this is operations. Right, this is a warm room observatory, so I actually have a separate building, separate place where I'm actually running the telescope from. And then over here on the right side, this is the live view in the middle. This is a live view, so if a satellite goes through, you'll see it go through. And this over here is the camera control. And we also have cameras that are peeking into the observatory, which we'll bring up as necessary during the night. And those will appear down here in the lower right. So, that said, why don't we actually take ourselves over? Oh, well, one last thing. This is our dynamic planetarium. It's part of this. This is telling us exactly where we are pointing as well. When I told you we were pointing at Antares, that's very true. And you can tell because when you zoom in, all right, this is Antares here, you can actually see that there is a little icon that says scope. And that's right where we're looking. We're just to the upper right of Antares, and when we go back in the main view, we are, in fact, just to the upper right of Antares at the center of the view. So we are dead on accurate. All right. Hello, Marianne Robb. How are you? And Bob, thank you for the compliment. That's a very nice thing to say. Bob says, I've learned so much from these streams. Thank you, man. Well, you have, of course, Daryl to thank. You have Amanda to thank, and you have me to thank if you wish, and that's very kind. Daryl has a lot of really good information, and SkyTour LiveStream would not be the same without him. So I think it's really cool that he's with us. All right, so right now what we'll do is we are going to head over to a different location, and we're going to try and find that Messier that Daryl wanted to see before. That was Ptolemy's cluster. And this, by the way, this is the view of the actual observatory site. That's my house, and there's a building office down in here, actually, where I run the telescope from. All right, so these are our real horizons. This is not, this isn't, made up, okay? Because there is the dome for SkyTour LiveStream, all right there. So these are the real horizons. Those are the real trees sticking up and getting in the way and things like that, and they are very, very accurately placed. Okay, so we're in here now, and we're at Antares over here, and we're gonna go to Ptolemy's cluster right here. So what you'll notice is you're gonna see the telescope is going to go from this place to another star that is near the cluster that's bright, and that I will tell you about as we do it. For right now, I'm going to start moving the telescope. I'm telling it to go to this location right now. Okay, you'll watch Antares disappear. Phew, there it goes. And you'll see the crosshairs start to move. They lag behind just a little bit from the rest of the system. Aha, but here's a star that it's bringing in. What star is that? It is bringing in this star right here. Okay, this is the target star we're looking at. And I think that star is that I can't even see the name of that star. Is it Fuvu or something? I can't even see.
It's very tiny on my screen. I can't.
Yeah, but that's okay. And then, of course, we head up to once we get to that location. Okay, it's using Mula. Sorry. So it went there. So you can see there's Mula right there. And then, of course, it's going to jump up to Ptolemy's cluster as soon as it can. And when it does so, we should see Ptolemy's cluster moments from now. And that is how it works. Oops, sorry. That is how it works. That is how we get to see the things we wish to see. And right now, it doesn't look like it's there. Yay for all that. But I can actually make sure that it gets there. Sometimes it does that. So let's do this again. I've actually noticed there's database errors in the telescope database at times. And that's actually kind of weird. Now, the other thing is the dome itself can interfere with what we're trying to look for. Only because, and see now what it's doing, it's trying to go from this star that it went to first. I was trying to go down to this star down here. And it's doing that, I think, because it could not locate the star that it was trying to locate. And that does happen. That could be because the dome got in the way, and so it tries over and over and over to find it. So, but let's see if it will do that. Alright, let's do this here. Yeah, very strange. Okay, I think we can probably work this out a different way. It could also be that it's kind of low in the sky too, and that could be causing problems. But let us try. Let's just try. Let's go here. Let's go to the Southern Ring Nebula, and let's try that first, and let's see what we get from that. So it's on its way, and it goes to a bright star that it can see, and in this case, it's the star Klaus Media. And that's going to be the alignment star. And from there, it should know exactly how far it has to go to get down to this object. I'm thinking that the dome was partially blocking it, and that's why it couldn't see it. So this is what we're seeing. This is the star, and then you'll see after it gets centered right about there, then, of course, boom, it's going to take off and head to this Southern Ring Nebula object. Okay, and here it comes. And what I'll do is here, so it's going to be in here. I predict it'll be right in there. And what I shall do is take an image of it just to show. We know the Northern Ring Nebula, the Ring Nebula in the constellation of Lyra. And while we're here, I figure, why don't we just take a quick shot of it? We still have time to see Daryl's that he'd like to see. So on this side, this is the sensitivity of the camera that I'm adjusting. It goes from 50 all the way to 409,000 ISO. That's a very, very fast camera. But the farther up the scale you go, the more grain, the more noise you get in the image. Okay? So you have to wait about 11 seconds for the guiding star to be grabbed. And so we'll do 5,020 seconds, and we say go. All right, and so we did 5,000 ISO for 20 seconds. I can set the time here for the exposure. All right. So that's pretty cool. Okay, then as this gets done, ooh, there it is, right there. I see it. Now you might say, well, wait, I barely see that. Yes, that's true, and that has to do with the fact that we are taking the picture with a filter that will show only the most, the faintest data can get pulled out of a nebula, but it's not going to be the brightest object. It's meant for doing processing. So what I'm going to do is I'm going to go to the next filter, which is filter number 2. Okay, and you'll see the sky's a little brighter here now because now we're going to do the same exposure All right, 20 seconds at 5,000 ISO. Hello, James Dugan. Great to see you here. James is from Australia, where his skies, if he goes out to like sighting spring, I mean, oof, the skies there are spectacular. Okay, we're actually down in some murk here, but we do have a lot of stars in this image, but we do have to. Oh man, look at that! So this is the Southern Ring Nebula. It's beautiful, but I'm also noticing this haze. We're seeing a haze in here, and there's no moon tonight, which is really good. But we're seeing haze from the water vapor in the air tonight. So what I'm going to do now is just go back to our main view, and I'm going to go up by 2 stops. That means take the ISO up by 2 notches. I'm going to go up by 1 stop. So I'm going up 3 stops, okay? And now we'll take another picture, 25 seconds. The nice thing about SkyTour LiveStream is that all of our pictures are a minute or less. There's times when I will actually take 2 to 3 to 4 to 5 minute shots, and they really are beautiful shots. And when it's a gorgeous night, I will spend that kind of time to get this, get the right shot, So Carol, while we're going here, tell me who you had on Obsidian Curtain lately on your show.
Well, okay. Well, it was yesterday. It was a 2-hour special, man. The first hour, well, speaking of storms and weather conditions, I was set to have Renee Barnett of Night Vision Radio, and lots of television production of strange things, as my guest. And actually, from the previous Friday, well, it was a no-go, so we had to toss in a replay, and we tossed in, by my choice, Marianne Robb. Hey, Marianne, I see you in chat.
She is in chat.
Yeah, so we tossed up her show, but getting to we were lucky. Bill got his generator powered up on Tuesday.
Good.
But it was kind of like from the beginning, it was like dicey. 20 minutes after we finished recording Renee Barnett to play this last Friday, the generator blew up. So, we were just under the wire for that. Wow. And she's really interesting. And then it was followed by an hour with Lon Strickler, who has the website Phantoms and Monsters, Pulse of the Paranormal.
Wow.
And that was actually live and very, very interesting. We talked about black-eyed kids, etc. And it's in the archives at Spreaker, or soon will be, both of those shows. So, yeah, it was fun.
Fantastic. So make sure you guys pick up that show, watch it on archives, in the archives at Spreaker. And the archives, I believe, are they free? The archives free?
Spreaker, I think they are, because I don't have any membership or pass or anything, but I was able to access them. Okay. Yeah, the KGRA archives themselves are getting all switched around and perfected, as is the website. So
that's right.
Yeah.
We're in the middle of I was in focus mode, by the way, guys. That's why you see what you see here. That star is the one I've been using to focus. So I thought Carol could tell us about that while she was doing she could talk about her show while I was doing that. So that was good. Thank you, Carol, for that.
Oh, well, you're welcome.
All right. And now what I'm going to do is take one more shot of this with this particular filter, and then we're going to go to Ptolemy's cluster. We all know what a jewel box is. And if you've ever seen a real jewel box of stars, then you know where I'm going with this when we see these clusters that we're going to look at tonight. Some of these clusters are so stunning that you just have to stare at them. Now, for those that want to stare at these longer than I have them on the screen, all of these images are going to be up on... This focus is better. All of these images are going to be up on the archive at SkyTour LiveStream on Facebook after we do this. Okay, and here is, now you can see this red outside to the nebula. See that? Yeah, this is red in the outside, and it's got this greenish blue in the inside. Now, this reddish can be one of two things. It can be hydrogen alpha, which is an excited hydrogen atom, or it can be neon as well. And then this greenish blue in here, these are oxygen atoms that have been ionized not once but twice. It's called doubly ionized oxygen, and this is a planetary nebula. All right, and this is like the end state of a star. You can see the central star just barely right there. It looks a little bit off center, but we're looking at this object. It's actually really low in the sky, relatively speaking. So it's going to obviously be something that is not going to show as well as it could. Now, what we're going to do down in Arizona is we're installing a second observatory, and it's official. I'm going to be flying out on August 15th. We're going to be building the observatory building, and we're going to be making the roof. Now, the roof is going to be separate, and then we're going to be making posts that are off the building, and the roof is going to slide off the building when we actually open the observatory. Now, this observatory here is using the exact same circuit and program that I wrote to run the observatory. It's going to run the one in Arizona as well. So it's really going to be very nice, and it's going to be a good a system. I've been really troubleshooting it here like crazy. And Marianne knows that. Marianne is actually helping tremendously to get this whole system up and running out in Arizona. Now, where in Arizona? Well, I'm not going to tell you exactly, but I will tell you that it's in the Sonoran Desert, and it'll be at an altitude of just about 2,000 feet, but it's going to be in a place where when it's cloudy just 20 miles away, it's totally clear out here in Wickenburg. And I think that's in that Wickenburg area. It could be cloudy in Wickenburg, and then when you go out into the Sonoran outside of Wickenburg, you'll definitely see a beautiful sky. All right. And now, what are we doing here? Well, this is now Ptolemy's cluster that we're going to check out right here. All right. This is down in the southern sky. Well, you say, well, how far down? Well, it's only like 14 degrees above the horizon, so we're gonna check it out. So here it is, and you'll notice the stars right away. You'll notice they kind of twinkle a little bit. This is kind of what you'd see through the eyepiece, maybe a little better, but if I drop this down to say 5,000 and do a 20-second shot of this cluster, I think that you'll see some beauty here. Daryl, is there anything specifically about Ptolemy's cluster that you wanted to mention?
Oh, it's Messier 7, the seventh object on Messier's list of comets, of objects that are not comets. It's the farthest south of all the Messier objects. It sits close to M6, the butterfly cluster, which hopefully we may be able to see also tonight. The dome was in the way the other night.
Yeah.
I was wondering what Messier's rationale might have been if he had a search pattern or whatever. Sort of, when we look in this part of the sky, you have a string of Messier objects that all are running from sort of south to north. When you started on Antares, actually, M4 globular cluster is right next to Antares. But then moving on over, M4, next is M5, which is a globular cluster up in Serpens, if I remember correctly. And then you've got M6, M7, and M8 is Lagoon Nebula, which was a popular viewing object here. The Lagoon Nebula up just above the spout of the teapot in Sagittarius. And from there, you have M9, which I think a lot of people forget about, which is a globular cluster up in Ophiuchus, the serpent bearer, the guy holding the snake. I don't know if that means he was looking by right ascension or what, but, if there is really any rhyme or reason to what his search patterns might have been.
Yeah.
We do have a string of M objects, almost all, numerically in a row here.
I do wonder, what must have been going through his mind.
No.
And I do want to, this is, if you notice here, folks, it says the small Sagittarius star cloud. Well, we're looking more or less toward the center of our galaxy here, and Daryl mentioned that to you guys the other night. If you were listening to us then, and we're actually looking right now. Well, from where we are, looking at Ptolemy's cluster. I'm sorry, right down here. Okay, it's from Ptolemy's cluster. We're not that far from the star cloud and where it begins. You see it up here. But let me show you. If you look in this image, you can actually see that we've actually got quite a few stars in here for just a 20-second shot. If you take a deeper shot, then there's even more. And so we're gonna try and do that here in a little bit with the Milky Way. It's clear tonight. That's what I'm saying. It's clear, but it's really not the best night. But we're gonna make the best of it. I can tell you that. All right, now, so this is M7 and M6. Which way is M6 from here? The butterfly cluster right here, correct?
Yes, butterfly.
Yeah, there's the butterfly. And what we'll do, because our telescope is pretty well aligned, I'm actually going to just drive the telescope manually on over to it because I can. All right, so I'm going to get into the computer and speed up the rate a little bit. And now you'll watch this moving across the sky and up toward that. So we're going to go north first. Okay, there we go. All right, and then we're going to go toward the west. And the cluster will be coming in here momentarily. And there it is. I went a little too far, so I'm just going to come back down, lower the rate a little bit, and just drop back some. We're going to drop back some, boy. Here we go. Mm-hmm. There we go. Yeah, and this is now the butterfly cluster, which is right here. So let's check out the butterfly cluster. Now, every time I move the telescope, we have to give it time to catch the guide star. And that will take approximately 11 seconds. Literally plus or minus half a second. It's really accurate, So now we do that, and I'm just going to go to 25 seconds here at 5,000, and we'll say go. Also, my big glass of water.
Haha.
I've told people I've been drinking water for about a month and a half, 2 months now. I've been drinking water all day and then having a regular meal at night. And you know what? The weight has just melted off. I was 198 when I started, and I was 178 this morning. So that's 20 full pounds. Easy weight loss.
Yeah, congrats. I'm doing the same thing, and I don't have exactly that poundage, and I'm certainly not going to tell anybody what I weigh or, what I weighed when I started, but it's relatively painless. It's your body gets used to, having that one meal. Sometimes I fudge, and it's not 6 o'clock, it'll be 5, but yeah, but it works.
Yeah. Hey there, Keith. Keith from P&K Space Imaging is in here. Folks, if you have not subscribed to P&K Space Imaging, I recommend you do so. P&K, they are the purveyors of the finest shots of the moon you may ever see in your life with a telescope. They have it down to a science, and I really think that they are much more worth the visit when they're streaming the moon than any other stream on YouTube. So check out P&K Space Imaging and talk to Paul and Keith, who run P&K. Paul is in Miami, Keith is in Pennsylvania, just like Carol is in California, and Daryl is in Colorado, and I'm in Connecticut at the moment. In a couple of weeks.
Isn't that astonishing? Yeah. We just take that for granted now, right?
Yeah, and as the Arizona Observatory starts to come online, then I will be operating the Arizona Observatory from here as well for a period of time, but going back and forth quite a lot. Because I don't want to leave my baby out in the desert all by herself. No.
Right, with all those scorpions.
I hunt scorpions out there. I mean, ask Marianne.
Yeah, I know that. Yes, right.
At her house, I found scorpions in her woodpile. When they didn't think there were any, I went out there and I found them. Because scorpions, okay, if you take an ultraviolet light, scorpions glow very, very bright. You can't miss them. You can aim an ultraviolet light, a black light, you know, and you can buy an old UV light, a simple one for like $10 at Walmart. And I aim it out there into the darkness, and they stand out like a beacon. They can't hide, those poor things. I really feel bad for them. I really do.
Yeah, they're much maligned, and I guess the bite is certainly not, or the sting is certainly not fatal. What color do
Not
they
those.
show up?
They show up as a bright whitish blue. Yeah, it's really like they glow bluish white. Hey, Kathy Prentice, how are you? Nice to see you.
Yeah, howdy, Kathy. Yes, indeed. Hello.
I think I said hi to you, Bobby, but maybe I missed you. Sorry. And Katie Q is here. Hello.
Yay.
Hot curry scorpion with steam. Okay, you know, Katie, that's just not
all right.
good.
Yeah.
Katie Q. You know, I didn't
Steamed rice. I could go for the rice part, but
I didn't eat any dinner, and now I won't. I'm kidding, Katie. You're fun. Hey, Brandon, how are you? Beautiful sky in Pittsburgh. All right. Yeah, the stars are out. Yeah. We are looking at the other nebula that Daryl had requested. This is Messier 7, or is this 6?
6.
Yeah, thanks, Daryl. It's Messier 6, the butterfly cluster.
Butterfly cluster.
Yeah. Yeah, Daryl had asked specifically for the butterfly cluster, and I said, heck yeah, let's do it. Let's do it early on, because he was not, we weren't successful in getting the view the other night. But now we did. Look at that. It's really
Gorgeous.
pretty. Yeah. I want to point out to you guys, see these. What's that, Daryl?
Oh, I was just going to say, maybe you were about to say it, has that one very red star among all the other white stars.
Yeah. Yeah, that's right. That's exactly right. And this red star right here, you know, and I have to look and see what kind of star which star that was. I can actually figure that out for you guys, because I want to tell you a little story about these stars too. Let's go in here, and this is the red star we're talking about. It's actually called BM Sco, or BM Scorpius, and the star is a fairly massive star, and I have to figure out the spectral type here. It's a supergiant star, and in our scheme, when we look at supergiants and we look at other stars, we classify them effectively by color, and that color classification is O is the hottest and bluest, and then there's B, which are blue, A, and the temperature drops on the scale as it goes. So it's O, B, A, F, G, K, and M. Okay. The K stars tend to be a little more orange. Okay. The G stars are what we are. We have a star, the sun, which is a G2. So it's actually a little bit yellowish, but whitish yellow. And then the F stars, which come before us, are whitish yellow. And the G's are a little more yellow as they get to like the G3, 4, 5, 6, 7, 8, 9. Okay. And then the K stars are a true orange star. This is a K star, this one right down here. And that's that guy right there. This is a K star, and it's actually called a K21b, meaning it's a supergiant star. All right. And supergiant stars can be quite far away. All right. And still show up very brightly because they're so big in diameter. Okay. Another supergiant star that's about the same distance as this one, is one that we're very familiar with in the winter sky. It's called Betelgeuse. Okay, this star is 787 light years away, and Betelgeuse is around 750. And the difference here is that this star is a K21b. Betelgeuse is a star that, being also a supergiant, but it's bigger in diameter overall. It's much bigger, and that star is going to be one that might be going supernova if it hasn't already. Now, that's kind of good news for us, because we might get to see a supernova in our local neighborhood, so to speak. It's kind of local to us, 750 light years. But when it does go, it's definitely going to be a sight. It's going to become a daytime star. So if Orion is in the daytime sky, because the sun, as we go around the sun, the background stars behind the sun are the things that are the constellations that the sun's going through as we're seeing the sun superimposed on those background stars much further away, but we can't see those background stars. But if Betelgeuse goes supernova, even with the glare of the sun, even with the blue sky that's caused by the solar radiation hitting the air molecules and causing them to scatter light, and mostly high energy light, which is blue, even with that, Betelgeuse might still be a daytime object that you can see in the daytime sky. It'll look like another star in our sky during the daytime. I have shown people and that you can see Venus during the daytime if you know where to look. And we have often had daytime Venus watch parties where we'd actually have people look in the sky and you'd say, okay, now it's all blue, so you have no reference points, but you basically set up a telescope and show people Venus in the daytime sky. And they go, wow, it's Venus in the daytime sky. I just said that. But what you also do is you then say, now you can see it with your eye. You don't need to actually use the telescope. And you want to see that? Okay, you look where the telescope is pointing, and then get behind the telescope and kind of look along the barrel, and then move your eye to the side, and you'll look up there, and you'll say, "Wow!" And I've heard so many people go through that wow moment where they go, "Oh, I see it, I see it, I see it." And if they take their eyes off it for 1 second, it's gone. They can't see it again. They need to use the telescope to find it again. So bright stars can be seen, and planets can be seen during the day. And Betelgeuse, the only star you can see during the day now is our sun. And the other stars that you can't even see Sirius during the day, which is the brightest star in the sky. So Betelgeuse is going to be many orders of magnitude brighter than the star Sirius, which is the brightest star in our whole sky, when it goes supernova. That's possibly, we don't know for sure, but anyway, so Betelgeuse is kind of like a star like that. It's an orange supergiant, a red supergiant star, and it's really a star that's in its death throes. It has lots and lots of expelled star stuff. It's stellar envelope, we call it, around it, and it's actually quite an amazing star to look at in the night sky. And we watched it
a few weeks. Oh, I'm sorry.
No,
go ahead. I have a question though.
Go. Yeah.
Oh, okay. Well, a few weeks ago when Betelgeuse was doing that funky kind of stuff and it was getting brighter or dimmer, and there was talk about, well, it's going to happen right now. It's settled down again, right?
Yeah.
It has.
Yeah.
Okay.
And Daryl can tell you about that as well, because he was very clearly following that. He actually followed the brightness of it. We talk about things in the night sky as having a stellar magnitude. And that's the brightness that I'm an astronomer, for those who don't know. That's what I went to school for, which is why I can talk about these little white dots and know what I'm talking about, kind
of. Kinda. You think?
Well,
Wow.
So and my whole approach has been to try to find planets out there that may support life as we know it. And the reason I say that is because life as we know it is probably the type of life we'll find most often in the universe. And that's carbon-based life, And we can talk about that later, but let's get to some other objects, okay? So, Daryl, we have shown your favorite 2 objects for this location. The one, well, not your favorite, but the ones you had requested.
I have a question.
You may ask. Go for it.
Is it safe to infer from what you said about the orange star that it does not belong to the cluster? It's just a chance optical alignment?
Yeah, as a matter of fact, that's a very good point. Now, we can test that right now. Let's go back into our thing. Now, it's also possible that this star has been part of this cluster, and if this cluster's age is such that this star actually has gone to its red giant stage, then maybe some of these other stars are going to follow. See? But that's okay. So this star, BM Scorpius, or Scorpii, BM Sco, we call it. This star here is 787 light years away, and this star here in the cluster is, if it has a distance to it, I don't see a distance.
I just looked up the M6.
Okay.
You said the orange star was 700 some odd light years away?
Well, that's what's stating in here. And, we know that, it's a 787.82.
Okay. Wikipedia says the cluster is 1,590 light years away.
Okay, and the cluster consists
So it's actually a foreground object.
Yeah, if they're not considering BM-SCO as part of that cluster, and if the data is correct in this program. But you're right. And when we look at a cluster like this, the stars that we see in clusters tend to be on the bluer end of things. Why is that? Because they are younger stars. You get clusters that are formed from lots and lots of hydrogen gas that's present in these interstellar clouds. And when the stars begin collapsing, there's little areas within the clouds of gas, of hydrogen gas, where the material begins to collapse. And collapse, like knots of area just collapse and collapse. Each of those gather more and more gas as they form a higher mass object. And these collapse into eventually potential stars. Many of these stars are about the same age. So we can, if we were to do some work on this star right here, okay, and we determine, say, that this particular star is part of the cluster, and then we look at this star over here and we say, hey, this star over here is also part of the cluster, and if we were to look at that, then maybe we would be looking at a star that's about the same age, if we can determine that they are both part of the same cluster. Because
right. I assume the Pleiades would be a classic example of that. They're all
good call.
Similar age, and they're all of a similar spectral type.
Yes, of course, he's right. Daryl is very knowledgeable about these things as well, and I think that when we look at these young clusters, or any cluster, then we have to look at the fact that the stars in them may look like they have different colors, and we would either say those are foreground objects or background objects. So the cluster could be here, and then a foreground object even closer, or maybe behind it, And if it's behind it, okay, then you may think that it's part of the cluster, and it's not. So that's how that works, and that's what this when we study clusters, we actually look at the clusters and figure out how they're moving, and we figure out something called proper motions. Proper motions are the motions of the stars in space, and we can also figure out the motions of the stars as they're going around the galaxy. And you'll find sometimes that you'll have stars in a cluster like this are all moving in roughly the same direction, because they form in a certain area and they're all moving together for a period of time. But then stars that are in the foreground might have absolutely no motion that's related to any of the other motion. That's another way to determine whether the stars are moving together, or whether they belong together or not. There's a beautiful cluster down in the constellation of Puppis, the Poop Deck, and I think this is M47, Daryl?
M46.
M46, thank you. Daryl knows where I'm going with this. M46 is a wonderful object in the sky. It's a cluster of stars, and in the middle of this beautiful young cluster of stars is a planetary nebula. A beautiful, round planetary nebula. It looks like a tiny little ring nebula, effectively. And you look at that and say, that astronomically makes no sense. That shouldn't be there. That should not be there, because of the fact that young stars are in the primes of their lives, if not too young to even, they're too young to date other stars, for crying out loud. I mean, they're young, so the stars are not advanced in age yet. So why would you have a star that's in its final years and its death throes? You see, it makes no sense. So you study the proper motions, and you see actually, and study the distance, and you say, that star that's a planetary nebula is actually 2,000 in this particular case with M46 and Puppis. It's a winter constellation thing. We can't see it tonight, sorry. M46, that cluster is over 4,000 light years away, but the star that has the planetary in it is 2,000 light years closer to us. So we're seeing things in what look like 2 dimensions on the sky, but you've got to remember the universe is 3-dimensional. So things can be further and closer, and brighter stars are not necessarily closer to us. All right, that's another illusion that the universe creates, and it's absolutely untrue. So this star, okay, and this star here in the cluster, I think is like, it's listed as 880 light years away, and that's fine. It could be, and then some of these stars might be farther away, and some might be a little closer, but this one is 787 light years away. It could also be that this cluster of young stars formed elsewhere and then just happened to pass by or through even, this star. Okay, not through as in through it, but I mean encompass it as they went by. They could have circled it, So there's a lot of possibilities for how this stuff can work. The universe presents many, many puzzles, many conundrums, and I think that's probably part of the reason I love astronomy so much. If you have any questions...
Can we take a moment? Let's just admire the cluster. I wanted to ask the people in chat, does anybody else see a butterfly?
I see the butterfly.
I see it.
I'll give a hint. This is his body right here.
See, I was thinking that was a wing. Oh, well, no then. Yeah, the body. Are those 1, 2, 3, 4, 5 slightly up right there? Is that a wing?
Or
part of a wing. There's a whole loop going up, which is like that's the upper part of one wing. There's a slightly bigger loop down below, which is the top of the other wing. You know how butterflies have sort of 2-lobed wings, an upper and a lower section?
Yeah.
Right.
Then the parts to the left, you can visualize 2 more loops out of that. Those are the lower wings.
Are these the antennae?
I'm trying.
Are these the antennae?
Oh.
Because I thought the body of the butterfly is like right in through here.
Yes, it is. That's
yeah.
the body. And
are these the antennae?
Now
then?
I do. I'm seeing it now. There we go. That works.
Yeah. Now, I don't think that when we look at this now, it's really up to you how you see it. If you don't see a butterfly and you just see dots, well then join the club, because I'm a right brain, I'm a right brain thinker,
Yeah.
So I'm actually very creative. So I think does that make me left or right brained? I forgot now.
I never get that right. I'm the wrong person to ask, but
actually, no, it's just not true. I know that because I'm a left-handed person, and only left-handed people are in their right mind.
That's absolutely
I didn't
great.
know that about you. I'm also a southpaw.
Yep.
I'll be darned.
Okay, I'm glad you see it, Daisy and Zoe. That's good. Daryl's explanations are very good.
If we were to connect those dots, could we come up with a butterfly? Would that be the way to do it? Like,
yeah, but
actually
I'm not draw
print that out
and
take a pencil and.
Yes, but if you printed it out, you probably could.
Yeah. Okay.
Homer Simpson saw cowboys in the sky.
Woohoo!
Yeah, but that's Homer. Oh my God. Yeah.
Marge.
Thank you for indulging me, Mark.
No,
Carry
that's
on.
fine. That's really good. Thank you, Daryl. I'm glad you pointed that out because people are responding to that in the chat. And by the way, Fantasy, hello. I didn't say hi to you earlier. I apologize. Anahata77, nice to see you too, Bonnie. Good to see you. And Lynch is here too. Very nice. That's Kyle. He's here. So this is good. So now let us bring up our planetarium here, and it's our telescope control program too. I don't have to use this, but I do because it's very visual and shows very nicely. What I'm going to do now is just to show a little bit more of what's going on in the sky. I want to go to an area where there's some very dense stars. I think I say very dense stars, very dense, high density of stars. Let's go with a Tom Thumb cluster right here. Okay, this is NGC 6451, and this is a cluster that's in a very robust and voluminous section where there's a lot of stars. And when we take a photo of this at that point, you'll actually see, a tremendous amount of detail. There's also nebulous detail and nebula in here, but I'm not sure we'll be able to capture that today. We will see. Once we get our star set up there, you see it takes off, and now it heads over to the cluster, and the telescope lines up and brings us to the cluster directly. And what we'll do is, I can do this. I can go into my high vis section, see if we've got any dome issues to worry about. Out in Arizona, we will not. Well, there it is right there. Look at that. I think it's actually a little to the left. But we're doing this live 4K view, and I'm going to just head over to the east a little bit. Okay, this is live in the telescope. Alright, so we're going to go right there. And because what I want to do is show you all the stars that are in this area. We're going to go to the Sagittarius star cloud as well and see even more stars. And we're going to do this at 25 seconds at 6400 ISO. So 6400 ISO here, 25 seconds here. And here we go. And then when we come back, it'll show us some more details here. We'll see this. We'll see it show up here. All right, and this is the old one. Okay, this is still in the Milky Way, but a little bit further out. Now, when we get the next one, you'll see that it's going to be has a higher density of stars. Okay, and you can see that. Look up here. This is the cluster we're looking for here. And if you look at these stars, you can see that it's literally almost all stars in here. Okay, and there's the cluster. All right.
I see a little guy tipping his hat in the cluster.
Well, that's the Tom Thumb cluster.
That's a challenge.
Let's all have what Daryl's drinking.
Yeah, right. Oh, is it a bow-legged guy?
Actually, this is the hat. This is the hat.
That's the hat.
Yeah, I see that. Okay.
Here's the head.
I see the hat.
And his arm. There's his head. There's his left arm.
Yeah.
Oh, right. So just a guy like from the waist up, tipping his hat.
Yeah.
He looks like the Monopoly guy.
Yeah.
As Captain Kirk said, too much LDS in the 60s, okay?
Yeah, right.
Yeah.
Remember that? Yeah, trying to make it sound like something he understood. All right. Let me just do one thing here. Let's go bring this cluster. I know I moved it a little bit, and I didn't. I wanted to see that. Oops, went the wrong way. I want to bring it over this way a little. All right. And then I'm going to bring it down a little bit south. Actually, north. Okay. And now we're going to go and take this picture again, but this time I'm going to take it at 8,000 ISO, go up one stop, and leave it at 25 seconds. And I give myself time. By the way, whenever we see the live view here, always be on the lookout for satellites coming through the view. It's a fairly magnified view, so the satellites, if you see satellites in here, they might go like this fast. Just so you know, they might go. They might go through pretty quickly. Okay. So when we actually initiate the photo, this image is held, and we're not seeing it live at that point. But here is the view for our wonderful area. This star is over here now. It's going to be down about here now. Maybe a little more. So, okay, there it is. All right, and this is that cluster. Now, I want you to see in the cluster, there are some really red stars. You see those?
Yeah, the colors are amazing.
Yeah, these are really red stars. Now, the purple background is just because of the nature of the filter we're using right now. And if I were to use the filter that doesn't have any, I'm sorry, the opening doesn't have any filter in it, then we would see some haze in here and it wouldn't look all so hot. So using the one I have, we've actually removed quite a bit of the haze entirely. And then we could actually go to our filter wheel here and go to filter 1 and just try that as well. So there's filter 1. That's this. Oops, you didn't see it. I apologize. I was over here. This is the filter section. So I was on 2 and I'm going to 1. 1 is a narrow band filter. This cluster has nebulosity in it, and you can see it right here. See it? See, this is part of the Milky Way complexity going on here. This here. That complexity there. So we're going to actually see if we can draw that out a little more. And the way we're going to do that is we're going to go to 12,800 ISO over here. And we're going to go up to 30 seconds and see if this helps us to see it. And we've also dropped down to filter 1. Filter 1 and 2 are very close in focus. You don't have to change the focus so much. But I might have to. Anyway, I'll just look at the result here and let you know. We'll see it. Now, if you ever want to see the colors of the stars really beautifully, one of the ways you can do it, there's 2 ways. One of the ways you can do it is you can defocus the image, okay? And if you bring the focus way out on a cluster, you can see all the subtle differences, okay? All right, so this is 30 seconds. I probably want to go to a minute and raise this even higher. So there'll be some nebulous detail here. So, but let's just, there's the cluster right there. Let me make it brighter by literally going up. Let's go to 25,600, and we'll stick with 30 seconds. So we'll go up 3, we call them stops. That's 3 levels, increments of exposure. And if you go up on the ISO, that is the sensitivity of the camera, by 1 and go down by 1 on the time, then it's a wash. The image is just as bright as the other one. But the lower this ISO number, the less noise you're going to have. And that's a very good thing. Okay. And so what we did was we did this 30-second shot. Okay. And we went up, and let's see what we got. Okay, really interesting. I'm looking. I always scan the skies too. You know, this is a really pretty shot. But this stuff here, all this stuff in here, this is noise. Okay, and I get rid of the noise when we actually do the processing. And Daryl and some of you that are fans of SkyTour LiveStream have actually seen, you know, what we can do to get rid of the noise, and it really is quite astonishing. You know, really, really, really astonishing. So I would have to go even longer exposure on this. But you notice that I didn't have to really refocus. What I'm going to do is I'm going to go back to filter wheel 2 right here. Okay, so I moved it to filter wheel 2. I know you don't see that right now, but I did it off screen. And now I'm going to come back to our thing here. That's our photo adjustment system, and I'm going to take the camera and go 30 seconds at 25,600 with this other filter. Now, what are the filters? Filter number 1 is what we call a narrowband filter of the whole spectrum. Okay, the narrowband filter takes just little slots of light from specific locations. All right, and that's what number one is. Okay, it's very, very narrow. Number two is it's using fatter bands. Okay, I know this is really annoying down here. What the camera's doing from on my face down here. I apologize. Okay, but it's a wider narrowband filter, is what it is. Okay, and when we look here, you'll notice that you can see some reddish haze in here. Now, if I took, say, 25 shots here, all right, and then I stacked them, you would see a tremendous amount of star cloud in here. You can actually see the nebula. See it? It's darker up here, brighter down here. You can see this nebulous detail. It's just beautiful in this region. You can actually look at the stream again if you want to see that. But I'm going to take us now. Oh, let's go up to our most favorite locations. All right, and I want to go. I gotta be careful because I may have to move the dome. Yeah. I'm gonna try this anyway. Daryl knew I was gonna go here.
Oh yeah.
Yeah.
Mark, you raised a question I've had a while.
Yeah.
Just like you did that overlay of your local horizon, your neighborhood.
Yeah.
Onto Stellarium.
Yep.
Is there a way you could put an overlay of the shutter opening on the dome to show you whether you're, going to be blocked or not?
Yes, actually, I started writing some software that would allow me to actually move the dome, at exactly this, to make sure it's at exactly where the telescope is. So as the telescope moved, the dome would move with it. And there's commercial value, programs like that out there. But since this telescope dome is going to go away in lieu of a roll-off roof also here in Connecticut, I'm not going to bother to put the time into that. This dome is going to be replaced by a shed with a roll-off roof. And then we're going to, literally I'm going to build it around the pier that's out there now. And then in Arizona, we have a 12-foot by 12-foot building that we're putting up. And in there, we're going to have, initially we're going to have 2 piers for 2 telescopes. And we're going to have a third standing by for a third. Hopefully we can get what's called an astrograph in time and use an astrograph there. An astrograph is a very, very fast, very big telescope. And I'm hoping to be able to use an astrograph at the Arizona site to take just stunning photos of the night sky as well. It's pretty cool. But so, can I do the overlay? I could, but I don't want to take the time to do that because it's not going to be here long enough to worry about. You know what I mean?
Yes.
Yeah. Okay, we're gonna go to. Yeah, we're gonna go to.
I was just wondering.
No, it's okay. We're going to Dead Man's Chest Cluster. So we're heading into denser Milky Way even still, and then when I take the photo here, you're gonna see an even denser stellar collection. Now, one of the things that I want to point out to you, and I'm going to go here, right here again. This cluster looks the way it does. It doesn't look like Ptolemy's cluster, right? It doesn't look like this other cluster we were looking at. Okay, let me get back to it. Let's see. Was that here? No. This one. Okay. It doesn't look like this cluster, right? And it doesn't look like this cluster. It actually looks fainter, doesn't it? It looks more like, it's a fainter object. See how much smaller it is? It looks fainter, and the stars look like they're not as bright. That's because they're farther away, perchance. And it's also possible that we're seeing what's called interstellar extinction, where there's dark dust between us and this cluster, and it's causing that light to, number one, be reddened slightly, Just like the sunset looks red because it's going through more air on the horizon to our view, and so it can be interstellar extinction, or it can actually be because of the fact that the stars are farther away and the cluster's farther away, so it's dimmer by that amount, or a combination of the two. So it's possible, you know.
So can you clarify the extinction part of that phrase?
Yes, extinction is where some of the light is removed because of the fact that it's being absorbed by and scattered by intervening dust clouds and dust particles in interstellar space. Okay.
Ah,
Do you follow
okay.
that?
It's not like they're going away.
What do you mean they're going like?
Are there like, we think of extinction events on Earth, etc.
No. Yes, that is correct. Interstellar
Yeah,
extinction.
okay.
Yes, you're right. Interstellar
Okay, good.
extinction
Thank
is
you.
not that. You're right. It is
Good.
it is the dimming of the light and the reddening of the light that is caused by distance and dust and other intervening material between us and our target object in the sky. If that makes sense.
It does, and thank you, because I was getting a little worried there.
No,
in my ignorance. Yeah.
No,
Okay.
no extinction tonight.
Yay. And that's a good thing.
It's a very good thing. That's a good thing, Miri. That's a very good thing. Who in chat knows what that's from? Daryl, don't say it.
I wasn't even thinking it. I don't know what you're talking about.
Okay. All right. Okay, here's another cluster, and you'll notice in this particular cluster, you have this beautiful, beautiful star cluster. But notice over here, we have a dark nebula. See these globules? This is a beautiful area of the Milky Way, and a long photo of this area would turn up some really, really interesting detail. You see all that, Daryl?
I see some of it.
Yeah. So this is a really cool area, and again, as usual, it appears that we have some stars that look like they're redder than they might otherwise be. So I'm sure we have some interstellar extinction going on here, and it's possible that these stars are. It could be a slightly older cluster too, but usually, when a cluster is this compact, it means that they really haven't been subject to a lot of the motions of gravity tugging and pulling the stars around and out of the cluster. We might have been part of a cluster when we formed. Yes, our sun might have been with others. And some of those stars that they think maybe we were part of were stars that form what we call the Big Dipper. Some of those stars, not all of them. It's possible.
Ursa Major moving cluster.
That's correct. It's the Ursa Major, of course, is the constellation within which we see the pattern of stars known as an asterism called the Big Dipper. And it's possible that this asterism, these stars, were actually part of a cluster within which we formed. So much like this guy right here. You know, when we look at this guy, these stars are all going to have motions of their own at some point. And they're going to be able to move independent of this cluster. Some of them might actually be ejected from the cluster. They might go zoop and orbit around and exit the cluster's gravitational tugging, at some point. They're held together by their mutual gravitation right now, and the fact that they just formed in space, but they all have gravity, and so they're all gonna move toward each other and do swinging around each other and start this pattern. If you look at these over a period of, say, hundreds of thousands or millions of years, you're going to see this going on. You're going to see the stars are all moving and whipping around each other, and some will get ejected, like I said, and some will go into tight orbits with each other. It's a very, very cool process. And we know all this because we study the motions, not just of the cluster as a whole moving through space as it goes around the galaxy, but we study the motions of the stars inside the cluster individually. So That's what astronomers do a lot of. Hey, D. Smith. So I think that, and Greggy Gilgan's here. Hey, Greggy. So there's a lot we can learn from these clusters, you know. And what we don't see is the nebula within which this cluster formed. It might have formed in the stellar nursery and over time blew away with its stellar winds all of the hydrogen gas that was left over that it was undoubtedly causing to glow. Because when stars are in a cluster like this, they will cause the remaining gas to glow. You know about the Orion Nebula. The Orion Nebula is powered by 4 stars in the center called the trapezium in part, and those 4 stars are very hot, and they can cause the hydrogen gas to glow that's around them, and it causes oxygen gas in this nebula to glow as well. All right, that's the Orion Nebula. So in the same way, the Orion Nebula being a stellar nursery, well, the Milky Way is full of stellar nurseries like this. And one such stellar nursery that we know about that's not too far away is right up here. Okay? And we're going to go look at that right now. This is the next stellar nursery on the list to check out. So, we're going to first go here. And I want you to be able to see this in view first. And then I'm going to bring up this guy. And we're going to say go here, and we're going to go to the Lagoon Nebula, and then we'll go to the cluster itself. So here we go. You'll see stars whip away here. Here they go. And then you'll see us go to the star that will serve as our signpost that'll point us to the lagoon. This process that I use is called high precision pointing, and it shows us exactly where the objects are, because it lines a star up that it knows, and then it goes the exact amount that it knows to get to the nebula. All right, and it's very high precision, so it's really getting it carefully in line. And then when it does it, when it's finished, it goes off, and then you'll see the stellar nursery show up, and here it is. This is the Lagoon Nebula. But wait, you say, where's the nebula? We have to see it in a time exposure, or simulating a larger telescope. If I had a very large telescope right now, which I do, okay, we could actually see the nebula, and as I increase the sensitivity of the camera, you can start to see the nebula showing up. Here it is. Okay, and it continues out all around here. This noise around the outside here, this pink layers around the outside, this is called amplifier noise, and it's not part of the scene, okay? But that's pretty cool. So, I'm going to get this down to, let's say 10,000, and I'll shut off that live low light segment there. And we're going to go 25 seconds at 10,000 right here. No, I'm not. I'm going to go 30 seconds at 10,000. And we're doing this with filter number 2, the wider narrowband filter. Let's see what's really hiding out in this nebula, shall we?
Oh, let's.
Yeah. May I say while we were shooting that just as we talked about M6 and M7 earlier, this is M8.
That's correct. You're right. Yeah.
Messier 8.
Yep. Messier 8.
I know there's a 13. What is the highest number of Messier?
110.
Oh my gosh.
Yeah. And those are all objects that you weren't supposed to look at because they weren't comets.
But of course.
Because Charles Messier was a comet hunter primarily, and he made a catalog of things to avoid. Oops. Okay. I guess that I had an issue. These shots are always kind of cool too, but you can see all the stars and their colors. Let me try another 30-second shot on that. One of the problems that the telescope has is it has what's called periodic error. And that periodic error is systemic to the drive, and sometimes when you take a shot, it's in the middle of trying to make a correction, and it might not work, and it might do what we saw just now, where it actually has this problem. I'm trying to just move my camera here a little bit. Hello again. So let's see
Yeah,
what we
it was a
got.
beautiful problem, though.
Yeah.
Oh, yeah, there we go.
There we go.
Oh,
That's a
oh
little,
my God.
That's a little better. That's a little more better, right?
Yeah,
So this
more
is the
better.
Lagoon Nebula, guys. Look at that. Isn't that beautiful?
Oh,
Now, we still have a little purple backdrop here, which we can eliminate, incidentally, by going to filter number 1. All right. And I'm going to go to filter number 1. This is the narrow band filter that I have. And we'll come back to this. Don't worry.
oh, the music's perfect.
I know, right?
Yeah, Katie Q says art shots. Yeah.
Yeah. All right, so here's what we're going to do. Now I'm going to go and do a 1-minute shot at 10,000. No. 12,800. Going for it. Okay. This is the old photo that we had, and now we're taking a 1-minute shot. 1 minute at 12,800. Actually, is it 1 minute? Or did I do a minute 30? Or 2 minutes?
Oh, I don't remember.
Oh boy, I don't know. I can't remember what I set it to.
I didn't see your bulb setting come up.
It was.
Or whatever you had bulb set at.
That's gonna be up in these settings here, which I'm gonna show you right now while we're taking the picture. Bulb shooting, and it is 2 minutes. Sorry. Okay, I'll make that 1 minute. But we'll actually be taking. We're gonna get a 2-minute shot of the lagoon here on this. It may turn out great. It may not, but we'll find out. But this is what it looks like.
The suspense, right? Oh,
This
yeah.
is- this
Is that
is-
shot number 1?
This is the first one, yeah.
Okay.
Yeah, and then we can remove some of the noise a little bit and see this looks a little better. Yeah. Yeah, and I see that we have a little. It's kind of a turbulent night out there, but you can see all these dark lanes here. These dark lines here, all these things. This is due to dark dust. Okay, there is no dark gas. Okay, it's dark dust, and it's mostly dust that is little tiny spindle-shaped dust particles that are all throughout this nebula, created in the hearts of stars and on the surfaces of stars over time when they went supernova. And then there's an hourglass shape right here. You see that?
Yeah.
Okay, this hourglass right there. Okay, this hourglass is right next to the. Well, that's even brighter.
Wow.
Yeah, that's an example of how it looks now. So there you go. There's a 2-minute shot of the lagoon. That's
I have a
kinda-
question.
Yeah.
Those dark lanes, do they change
They
from
will.
night to night or season
no.
to season? Or-
No.
Okay.
They don't change that you can see much within a human lifetime.
Mm.
Okay. Look at that, Daryl. Isn't that pretty cool?
It
This
is.
is that narrow band filter really shows off well here. This is the accidental 2-minute shot, and you can see that well, that's great. Just a second.
Come back.
Oh yeah, it'll be back.
Okay.
I don't know what happened there. Once in a while, it does happen, but there it is. It's back. All right. So that's pretty. Now what I'm going to do is go back and just take another shot right now on bulb. And this shot I'm taking is actually 1 minute, not the 2 minutes. All right. So get rid of this guy. Okay. So here, when you look at this, you see all this noisy stuff. I can get rid of all that. Okay. But I get rid of some of it right here just to sort of show you how it looks. But this is, you can see it better when you make it smaller sometimes. But that's the Lagoon Nebula. That's what we call a stellar nursery. Look how clear these dark areas are here. These are those, like I said, those dark lanes. And The star that's powering most of this nebula is that little guy right there, you know, and that's pretty impressive. This particular nebula is really impressive. So we're actually talking about this guy. It's right here, the little guy. That's a hot O star right there, and it's powering much of this nebula that we're seeing around us here. You know, yeah. And here's the 1 minute shot now. Okay, and it's actually quite nice. Let me remove some noise. Look at that. Wow.
Oh my.
Let me get my ugly mug out of the way and just let you see this thing. Instead of being... Yeah, look at that. Wow. That's really pretty. You know, I love these. Look at the intricacy in this detail here. This is the kind of stuff you see we do at SkyTour LiveStream, guys. We actually will take these shots and we will stack them together and make a sandwich, basically, of shots on top of each other. And when we do that, all the noise can be suppressed pretty much. And then we can actually do a very, very nice job of getting the final product out to you. And I make these all available to you, by the way. Yeah, all of them are
Which
available.
is extraordinary.
I like making them available. I like seeing what people can do with them.
Yeah.
Wow. Isn't that pretty, though? That's really pretty.
Gorgeous. Gorgeous.
It is just
D. Smith asked a question. How can we see the stars behind the dust so clearly?
Well, the stars are actually very bright. So when we actually look, for instance, like these stars you're talking about?
I'm not sure. This is a question from D. Smith.
Yeah, okay. All these little, this stuff here, these little dots here, and these little kind of weird shapes, that's noise.
Mm-hmm.
Okay. But if we look at the stars, we don't see the stars very clearly when they're behind some of this dark nebula. Okay. You'll see there's a couple stars here. Their light is undoubtedly being affected by this nebula. Right, and so, like for instance, like I'm talking about these stars, like this guy. Let's see, that star right there, and then this star right here. You know, right there. These stars' light is affected by the nebula. This dark nebula that you see right around here, it's causing the light to be dimmed somewhat. That's the problem with astronomy. Okay, we can't see into the dark nebulae with regular visual telescope like this. We need to pull out the infrared scope. And we need to look at the heat being generated. And when we do, then we will actually see, we'll see a little better. I'm going to try and just do one thing right here real fast. Go in and make an alteration to this. There we go. Okay, so now you can actually see it a little better. Okay. So the dark nebula then will obscure what's behind it sometimes. This is actually a glow caused by the stars that are ionizing this vast hydrogen cloud that's many light years long. Okay, it's ionizing this vast cloud, and so ionized gas is transparent, but it glows at the same time. Okay, so that's why these stars are visible here. But when you have actual dust, they can indeed obscure stars behind it. Okay, so that's something else. A great example of that is Hubble's Variable Nebula, which we look at a lot. That's, again, a winter object. But Hubble's Variable Nebula is a small little kind of V-shaped nebula. And we notice that it changes its patterning over periods of a few months. And that's because, in fact, weeks to months. And that's because Hubble's Variable Nebula has a star you cannot see hidden inside a nebula right near the bright part of the nebula. Okay, and it's inside of a dark nebula. And its light peeks out and escapes out into a brighter area of the nebula and will change how the nebula looks because there's dark dust circling around the star inside this nebula that you cannot see. We cannot see the star that's causing it to glow. And it's only reflected light that's making it glow. It's not light like this, which is the light of ionization, which is extremely hot light, high radiation, very high in the ultraviolet, and it actually causes the electrons in the atom to bounce off the atom, and that's called ionization. And then the atoms, the electrons outside the atom, now nucleus, are saying, hey, what the heck happened? And they bump into other electrons, and they lose some energy, and they fall back into the nearest atom. And they typically fall to one particular energy state within an atom. It's like steps, within an atom. Very discrete levels, okay? And these quantum locations, which is, of course, the reason we call it quantum mechanics, is because of these quantum locations are very discrete, and we can identify them. And the glow that makes the nebula reddish like this, all right, is the glow of a particular transition of the electron back into the atom down to a state called the N level. N is in November. An N state of 2. All right, when an electron jumps down. Now they go to 3, they go to 1, they go to 4, they go to many other states, but mostly they go to 2 when this type of excitation of the atoms is done. And that predominant value is what we see as the red light in a nebula like this reddish light. Okay, so that's pretty cool. Now, just to give you an idea of what we're looking at for skies and how these filters actually work for us, let's go back real quick to our main view, and I'm going to just grab our view here, and I'm going to take our filter, and I'm going to go back 1, and that's going to take us to filter 5, which is a white light filter. Now, it won't be in focus, but I want to show you something just to give you an idea. I'll drop this to 25 seconds at 10,000. Then we're going to just take this picture. I want to show you how the filters are helping us, because you saw all that amazing intricate detail. Well, this amazing intricate detail that you see will seem as if you can't believe that it was ever there in this next photo. So here we go. Yeah, let me just actually do this. Yes. Carol, you're going to say something?
Me?
No, I was asking Carol. I thought she was going to say something.
Oh, Carol.
No.
Oh, okay.
Just saying,
See
ooh
what
and
happens
wow.
when you put two people together with their names rhyme.
That's right.
I was just sitting here on mute listening.
That's
Yeah.
okay. Yeah. So as you can see, hi Cindy Murphy. So as you can see, this is a shot almost the same amount of time. All right, and look at the difference. Filter, no filter.
Yikes.
Filter, no filter. See that, guys? That's what you're paying for. Well, you're not paying at all, but that's what you get to see here. Is and this filter, just the filters alone for the telescope systems, and I've had to duplicate them, remember, because I've got a second telescope that's going to Arizona, outfitted with the same filters and the same setup. We're talking a lot of money in filters just to give you these views, and I'm just really just totally excited by this. Totally excited. I think this is so beautiful.
Well, the difference is dramatic.
It's very dramatic. It's this.
I mean, and that's an understatement. Yeah, right.
This is white light, what your eye would see looking through the eyepiece, right? And then this is with the filter.
No.
Yeah. Now they make filters that are meant for just looking with your eyes, and then they make filters like this one, which are meant for photography, so that when you take a shot, you get this, just beautiful. Oh, James Dugan, good point. Yeah, make sure that when you're streaming, make sure down below you're set to 1080p, okay? Because I forgot to mention that. Also, when we look at different objects, if you want to come back and watch the stream again, you don't have to sift through and look for where that was we saw a certain object, because I'm actually going to put them in the description. I'm adding tables of contents now to the videos.
Oh, that's a great idea.
I'm one behind. The last stream we had, I haven't finished that table of contents yet. But then I put that into the into the table of contents and then description down below, so you can actually just click on it and it'll go right to it. So it's a live link.
Oh,
okay.
Fantastic.
Yeah, it makes it a lot easier. All right. So this is the Lagoon Nebula Messier 8. And now when he looked at it with his telescope, he probably saw something kind of in between this and this. Maybe it could have been like this. No, not like that. Probably like that. He could have seen something approximately like that. Okay, and this is the wider narrowband filter. When you add the real narrowband filter in, then it becomes this. See the difference?
Oh.
So
when you said he, did you mean Messier?
I did mean Charles Messier, yes.
Messier didn't have a very good telescope. Going back, referring to M6 and M7 again, if you read his descriptions when he made notations on them,
yeah,
he said nebulosity without stars. And of course, what we see is all stars in M6 and M7. Plus, it wasn't a very big aperture. He probably didn't see a lot of the actual nebulosity in M8 at all.
Well,
it was a pretty fuzzy view, in other words.
Yeah, well, the other thing I was thinking, Daryl, is that, there's another option here, what you're saying can be absolutely correct, right? And we don't know. But it's also possible that Messier saw only a nebulous cloud. And maybe that cluster and the stars in the cluster winked on in the intervening years, and we missed it. We could have missed a cascading winking on of winking as like wink, turning on of a number of stars. I doubt it, but it's possible. And we have seen the universe change right before our eyes, in very dramatic ways sometimes. In 1054 AD, the Chinese astronomers saw a new star in the sky during the daytime. We look to it now and we actually see that it's the Crab Nebula. It's a supernova explosion by a star that's quite far away. And the Crab Nebula remnant that's left behind is an expanding mass of the guts of the star, basically. And over 100 years, we've been photographing it for over 100 years. You can actually watch it expanding in this little mini movie that they make. It doesn't go very far, but you're watching it expand. You're seeing the changes in the universe. They change on greater than human scales. So I think it's pretty interesting. And then what Daryl says is probably that, as he said, Messier didn't have a good telescope, but it's possible that he also, we can't discount the possibility that he saw the cluster, the nebula before all the stars winked on and were born, basically. And could it have happened within just a few years? Well, yeah. I mean, if you think about it, if you catch it at the right time, you can see a nebula that looks like this pink part of the nebula right here. That guy right there. And then tomorrow, if that train of light that's been coming from that nebula, if the train of light reaches you that shows the star winking on and starting nuclear fusion, that's an instantaneous effect. That's an instantaneous thing. So if you just happen to be there when all of the stars in the cluster winked on at the same time, potentially, and they may not all go on at the same time, then it's possible that that happened. And the way we'd know for sure is to get an age on the cluster. But there are.
I think you're reaching a bit there. Ptolemy saw M8 Lagoon Nebula 2,000 years ago.
Right.
And I think if those stars had the stars in the cluster there in the left half of the lagoon, if those had just winked on, we'd still be seeing the surrounding, whatever was left of the nebula they were born from.
Well, we do.
More dark stuff in there, in other words.
Maybe. But the dark stuff isn't the stuff that is what the stars are really made of. They're made of the transparent hydrogen gas that permeates the entire region. But no, my point wasn't the lagoon winking on, but like when you said he looked at Ptolemy's cluster, he said he saw he saw something different. Messier.
Yeah, he described it as nebulosity without stars.
Yeah. Now that could also have been due to where it was in his sky and when he observed it. You know, if it was very low to the horizon, then he wouldn't have seen nebulosity at all. He probably would have seen just stars. But if he was...
yeah, if I remember right, M7, Ptolemy's cluster, it's the farthest south of all the M objects. I want to say it's like about minus 35 degrees declination. Of course, him being in Greece, he probably had a horizon a little south of us.
Yeah.
But, it's all stars. It's a star cluster. There is no nebulosity.
Yeah, so...
And yet Messier described it as nebulosity without stars. If you go back and read Messier's descriptions, a lot of them read just like that. I mean, what we see as star clusters, he just called nebulosity without stars because he wasn't getting a very good view of it due to the quality and aperture of the telescope.
I would think that you would see the stars before you would see a nebula, though. Yeah.
You'd think. Maybe not if he doesn't have a very good telescope, though.
Yeah, there's something wrong with that. And not what you're saying, but there's something wrong with that historical depiction of him. Maybe. You're saying what is probably, popular
Well, let's
thoughts.
not belabor the point. Carry on, please. Would you excuse me, please?
Yeah, sure.
Just checking out Messier in Wiki, and to get the dates, he was born June 1730 and died in April of 1817. So that gives you an era.
Yeah. No, I'm not saying that star clusters just will turn on altogether, because they really don't. I mean, you'd see one start up, and then maybe 1,000 years later, 10,000 years later, another one or two might be there. I think there's that kind of delay. But I was just pointing out that we can't say that he didn't see only nebulosity there. He might have only seen nebulosity, but if his telescope wasn't that good, then I don't know how he could have seen anything. Never mind comets. But that's just me.
And we don't know about his vision as a human, do we? I mean, his eyesight.
He might have needed glasses too. That's the other thing. That's a good call, Carol.
Oh, thank you, Mark.
That's a good call. All right, I'm going to take us now to another object that I really think is beautiful. But we're also going to, you saw how it looks with white light. So I'm going to go back to our, I'm going to go back to our narrowband filter system here. You'll see the stars seem to go away a little bit. Okay, we're only bringing in the light of the hydrogen alpha, oxygen, and sulfur 2. What? Narrowband. Inside these nebulae, there's certain gases that are ionized to make the glow, as we talked about with hydrogen and so forth. And those gases, they tend to be this hydrogen alpha. They tend to be this oxygen, doubly ionized oxygen, so O3 it's called. That's not three hydrogen, and that's not three oxygen atoms. That means the O3 is the oxygen that has been doubly ionized. And you might say, well, wait, isn't O2? That's O, the O for oxygen, and then the Roman numeral 2, okay? But O3, O-I-I-I, the 3, Roman numeral 3, is doubly ionized oxygen. And you go, that makes no sense to me. It does.
Yeah, you go, I.
You're right. It does when you consider that O1, O with the Roman numeral 1, is the base state of oxygen. It's the oxygen atom as it is, as we know it, okay, with all of its electrons. All right. And so it's the non-ionized version of the atom. It's the base state, the lowest energy level. So now if you ionize it once, it goes up a level. So it goes from O Roman numeral 1 to O Roman numeral 2. Okay, so O, I. And then when it gets doubly ionized, it's I. It gets 2 electrons bounce off. And then when they recombine with the atom, they go to all different places, but predominantly go to one place where a greenish blue glow is generated. And that's why when we say O3 filters, we're talking about filters that look for that greenish blue glow, which is very prevalent in some nebulae. Okay, like the Orion Nebulae, the Dumbbell Nebulae, Planetary Nebulae. And then when we look at the hydrogen glow, that's very prevalent in these stellar nurseries, like the one we've been looking at, the Lagoon Nebula, and other nebulae that are nearby. So now that we have seen that one, I'm going to move us up, and I'm just going to drive us right to it because I can. All right, and we're going to just go from the Lagoon Nebula. We're going to go up, and we're going to just sit right here, head west a little bit. All right, and we go west. Go west, young man.
I was just going to say that.
I know you were.
Yeah.
And I went.
Horace Greeley, right?
I went too far west. Okay, so I'm going to come back here a little bit. And let's see. Yes. Okay. And now I'll just drop us down a little bit. Okay. I dropped this down a lot a bit. I didn't want to do that much. Okay. Now let's see. Okay, now we don't see anything here right now, but I'm going to just take a 25-second shot at 10,000 just to do a view. I think I see the stars right here. I think this is where it's going to be. I think that's where the nebula is going to be, but we'll see. We're looking at another nebula called the Trifid Nebula. It's north of the lagoon. And we should see it show up. Again, I think it's going to be right here. I'm about to find out. Yep, there it is.
Yeah, there it is.
And this is the Trifid Nebula, and it's actually got these really cool dark lanes. There's also a blue nebula that surrounds this star up here, and we'll see that shortly. Daryl's back.
Hey, Daryl.
Hey.
Hi.
Guess what this is?
It's an inexpensive British 60s science fiction movie.
That's
Day
right.
of the Triffids.
Yeah.
Well done, Daryl. I like that.
That movie scared the wellies out of me when I was a little kid.
Oh, I know. Remember how they sounded like?
Oh,
Yeah.
yeah.
Remember that noise?
freaky.
Yeah.
And they were like plants. They'd shoot out and grab you around the ankles and stuff.
Yeah.
And pull
Yeah.
you in.
Yeah.
Day of the Triffids. Yep.
But this is the Trifid Nebula, meaning
Yeah.
three-lobed.
Mm-hmm.
M20, Messier 20.
Yep. That's right. And when we look, I'm going to do a 1-minute shot here at 12,800 just to kind of give you a feel for this nebula. And we'll go back. I did a 25-second shot of it, so very short. But even in that, with this particular filter, you can see this gorgeous tri-lobed nebula here. This is one of the dark lanes, this is another one, and this is the other one. So it's got 1, 2, 3 lobes. And then it's powered by these 2 stars in the middle. Again, another stellar nursery. But what I like about the Trifid so much is that this star is home of a blue nebula. You can just barely see it around that star yet, and that's because I didn't take a long enough exposure. The 1-minute shot will really show it to you very, very clearly. All right, and we'll see how there's a blue glow around this one and this red glow around here with all this other detail that should be present. So let's wait for it to come in, and then we'll see it. Oh, there it is. Okay, and what do we got? Okay, look at the detail in that nebula.
Wow. Oh
look
my
at that,
God.
Daryl. Look at that. Is that you can see all this amazing detail in here?
Oh yeah.
I am so happy with that view. I have to bring us up a little bit so I can grab the blue nebula up top. It's not seen yet, not being seen yet. So let me grab it, pull it down. All right, so let's go up. Oops, maybe I went too far. No, I didn't. Let's do this and go to change the speed here. Okay. So let's go and bring it over a little. Go away. And can bring it over. And go up a little bit. Okay. A little more. Alright. And we'll just do a quick 20 seconds to make sure I have where I think I have it, which I think I do. It should be right here. I'm sorry, right here, and the blue one should be right about here, I think. We'll find out in just a minute. I've only got like 6 seconds left. And then we'll find out. Oh, yeah. There we go.
Oh, wow, wow.
Hey there, Raoul Duke. How you doing? Yeah, so we're looking for the, there's a blue nebula here. I can bring it in very easily by just changing the filter or going longer, but this is the finder shot. Let me actually give us our much higher, longer view here. We'll do 30 seconds at 16,000. Not even a minute. We'll just do 30 seconds. Yeah, Raoul, the stellar nurseries, when we look at where stars are formed, the nice thing is that there's no stellar nurseries near our sun, thank heavens, or thank the universe, because if there were, then we wouldn't be here. Stellar nurseries are visible by the fact that the gas is being ionized in there, as I mentioned, the hydrogen. So the stars are young and hot, and they ionize this gas. And you can see that this actually has a far-reaching effect. Okay, when we look at this Trifid Nebula here, I can get, like I said, I'll get the blue here shortly, but you'll notice it's pretty extensive. The filter I'm using is designed for doing really specific wavelengths, so certain things show up much better than others. But to give you an idea here, I'm going to go back now. And
was that the more narrow band of the two?
Yes, it is. And now we're going to go to the wider narrow band. All right. And nothing's changing. We're going to leave it so it'll be a little brighter because there's more stars showing through it. Okay. You can see those two stars in the nebula that power it down here.
Mm-hmm.
Okay.
Wider narrow band.
We're in the wider narrow band filter, yeah.
Is that like a jumbo shrimp?
Yeah.
Well, yeah, military intelligence,
Perfect.
business ethics, military intelligence, yeah.
Right.
What's going to arrive? Remember George Carlin? What's going to arrive? Is it going to be a big, is it going to be a big jumbo or just, kind of, remember that? Is it a little shrimp or a big, a little jumbo or a big shrimp,
And what's a jumbo, right?
Uh-oh. Okay, I didn't do anything different there. That means that the dome got in the way. The dome has entered our vision. So, can you and Carol take over for like 30 seconds to a minute while I go move the dome a little?
Sure.
Songs.
I promise not to sing this time.
Shoot. Well, I can tap dance,
Yeah, but that just...
that was all your fault, Mark. You told me to sing when you went out to work on the dome the other night.
I did.
So,
I didn't actually think you would do it.
well, I
Shoot,
couldn't think of anything else to say, so I sang a song.
I missed that. What did you sing?
Actually, I sang a few songs. I sang "Asleep in the Deep,"
Oh, I
and
love that.
then I sang 2 or 3 John Prine songs.
Wow.
I'm
Oh
going
my
out.
gosh. Well,
I'm
I
going
can
out to the
find that,
dome
I'm sure,
now
on
to
YouTube.
move it. So you might get to do it again, Daryl.
That's okay. I can sing harmony.
I'll be right back.
All right.
We'll be right here.
I'll be right back. I'll be right back. Hang on, folks. Actually, I'm going to give you something to look at while I go. This is the previous shot that I took. We'll grab it again.
Yeah.
Something I wanted to mention, Mark triggered a thought in my mind a while ago. There are some dark objects, like the clouds you see there, trisecting the tripod, and when we saw them in the Lagoon Nebula earlier, they're known as Barnard objects. Barnard was an astronomer back in the day, and he made a study of dark objects in the sky. Which are basically all large molecular clouds, sort of like what we see here. They're more prominent. It's the same Barnard that Barnard's star is named after.
I was going to ask that. Yeah.
Yes, same guy. But he made a study of dark objects in the sky, and here in Sagittarius is a particularly rich area for Barnard objects. There was an APOD photograph, astrophoto of the day, a day or two ago, showing what's called the Pipe Nebula. And it's so big you can't capture it in a telescope. You have to get a wide field view of it, and they have a very pretty picture of it. It sits right up above Scorpius on the west side of the Milky Way, and it looks for all like a pipe, like a smoking pipe, you know.
Wow.
It's one of the biggest ones. It's a very pretty picture. And there are quite a few Barnard objects up in the sky. Again, Sagittarius being a particularly rich area for them. Welcome back, Bart.
Hey there. I wasn't going to interrupt you, Daryl. It sounded like you were giving some good info.
No worries. I said my piece.
Alrighty. Now we'll take a shot here, 30 seconds at 16,000. I went out there. The moon has just risen, but it's like in like last quarter or so.
Yeah.
So it's only half as bright as it might be.
So no pesky moonlight. Well, not as much anyway.
However, I think the moon and Mars are at conjunction tonight, right?
Yes, they are.
Wow. Oh my gosh.
Yeah, they're close. You can't see them in the same view. But they're still really near the horizon, so it's not worth looking at it right now.
Yep. I've been watching them.
Yeah.
They're both in Pisces tonight, and I think they're closest tonight, so
Yeah.
you'd say they're in conjunction.
Yep. Well, there is. See, this is an example right here of. Okay, this is the Trifid Nebula with our somewhat wider narrowband filter. Okay. All right. So there's a little noise reduced one, and when we look at it with the narrowband filter, you see a lot more detail in here. So you see, you have to pick your poison, folks. Which filter are you going to use? Okay. And that makes a big difference. It really does. I tend to like using this real narrowband filter because we can actually see other parts that we don't normally see in the Trifid Nebula, like these wisps over here. Okay, you don't get to see all the stuff. And to see, what you do is you actually take these photos and, again, you stack them. You stack them. And when you stack these pictures, oh gosh, they are just beautiful. Now let's keep going up north a little bit. And we're going to go to another location I promised I would take you to. And it's this one here. We're going to the Sagittarius star cloud. I just want to show you what a region that's full of stars looks like. Really looks like, okay? And now we've got, this is our, we're looking at our alignment star here. And which one are they using? Or Caus Borealis. That's way down there. Okay, and then once it aligns, it's going to take off and head up to the small Sagittarius star cloud. So you'll see that it continues. It'll end up over here. Just a second. There we go. Yep. And so this, you don't see a star cloud here, do you? Nah, you don't see it at all, guys. No, there's no star cloud. Nope. No star cloud. Nothing to see here, folks. Oh, you want to bet? You want to bet? I will show you something. Hello, Starseed. Nice to see you here.
Hey, Star. Get rid of that headache, doggone it.
Oh, I'm sorry. I didn't see that, Star. I apologize.
Yeah.
Dave Schmidt. Here you are.
Hey, Dave.
Dave being his funny self.
Yeah, right.
Okay, we have our guide star. 30 seconds at 16,000 in the middle of the Milky Way. I actually noticed there's some clouds out there too, so we might encounter some of those, but let's hope not. You know, I'm sure they can be nice to us.
Yeah, we'll wish them away.
Yes. When you wish upon a star.
Oh, God, love it.
I just want to take a moment to tell people that if you're interested in the study of extraterrestrial life and want to read a book about the search for extraterrestrial life and why, look at, oh gosh.
Oh my God.
And why we think that the universe is full of, well, populated worlds, perhaps. You can read the book, The Populated Universe. Now, I wrote the book. It's available on Amazon worldwide, and you can get it in 3 formats now. You can get it in a big color 8.5 by 11 size color book. You can get a smaller black and white version, which is 6 by 9. You can get it in an ebook format, and soon I hope there will be another format that it'll be available in. But I don't want to say anything yet, in case Carol doesn't actually want to do it.
I kind of thought I knew where you were going with that.
Yeah.
Who doesn't want to do it? Maybe in some other dimension.
Do you want to tell people what you're going to do?
Oh my God. It's okay. I think that I'm going to get to do the audiobook. I sent Mark a sample in it, and it sort of got a 2 thumbs up, 3, maybe 5. I don't know, but I was 10 so thumbs. Nervous. Okay. Thank you, Mark.
It was really, really good. You folks, you haven't listened to someone who reads with emotion, and then you will absolutely love listening to Carol Carl read The Populated Universe. I wrote the book, and I couldn't stop listening to it, guys. I mean, not because it's like, look at me. No, nothing like that. It was like I was hearing it for the first time, because the emotion she puts into it. No, I'm sorry, Carol. I don't mean to embarrass you.
No, not embarrassed. Just like tickled pink. Okay, tickled as pink as that dome image was. Yeah.
Yeah. She was tickled pink.
Like that.
Yeah.
That's it.
No.
That's
no. The point being that when Carol was reading, I was feeling like I had only been hearing this for the first time. Why? Because you had to hear how she was saying the words, and she got it. She knew where the topics were going. She knows about the science to the point where she can actually say all the things that you're trying to get across with emphasis where it belongs. And when people try to do audiobooks, sometimes they kind of miss the point, right? They'll say things that are false emphasis, though. They won't give you the right emphasis at the right time. It's like putting the accent on the wrong syllable.
You're right.
Okay? Yeah. And that's what happens sometimes. I think that it's very important, though, if you listen to Carol read, I think you'll be very impressed. I really do. I think that it's probably going to be one of those things that you're going to say, "Wow, I can't believe that this is. I can't believe this is a book that. Well, I can't believe the book sounds so good. Is how it's going to come out. You know, because I felt like I can't believe it. No, it was so wonderful. Now,
you are so sweet to say. I want to say, first of all, long time acting background, a lot of news broadcast reading, copy, etc. But the main thing is that I've listened to you so much. I think I know your rhythms, right, and where you were, and I certainly know your sense of humor. And so, but I'm just reading your words. I want to remind everybody you wrote it.
Yeah, but you know what? You bring it to life, and actually, I just love it. No, I love it. I to listen to you talk, it's like sitting down with like someone that, at a restaurant or something, and you're just casually listening while eating your dinner or whatever. And I was see, here's the thing. When people do audiobooks, one of the problems with audiobooks is retention. Do you remember what was said?
Oh.
And I was studying this really, really, really hard because I wanted to make sure that Carol's words were going to be retained when I stopped listening. And yeah, okay, I might know astronomy and I might know what I'm talking about with some of these things, but let me tell you, I was listening to it as if I knew nothing because I wanted to hear how it would come across to an ordinary person who doesn't have, because I'm certainly not ordinary. I'm a whack job. Okay, I mean, really,
what a good one.
No, but really, I mean, who else would dance around the screen? Hey man, look at these stars up here, look at that. I mean, so the bottom line is that I wanted to see how it would sound to an ordinary person, and as I listened to it, I closed my eyes, and I was enthralled. It really was so good. I was like, wow, I've just never heard that kind of commitment, I guess is the word. Commitment maybe to the material.
Wow.
Yeah, I know. I'm just slamming it
well,
on
no,
thick
I'm
here.
just over the moon. Pun embedded and intended. But it's sort of again, you write and you present everything in such an accessible way to people who are, because I don't have a science background, and your words they flow. And so this was not difficult at all.
Well, then people have to get the audiobook and listen to Dr. Carol Carl reading, about...
the wizard just gave me an honorary degree. I thank you.
The wizard, yeah, as if.
Yeah.
Well, look, this is the Sagittarius star cloud, incidentally, in case anyone forgot.
Wow.
We're not seeing all of it. There's so many more stars in here that are just not present in this shot. Okay, and it's just stunning.
Gorgeous.
Yeah, it really is.
And a lot of color. I'm seeing a lot of color.
Oh, yeah. And by the way, that cluster right up here that we're looking at, that's NGC 6603 right up here. Okay. And what's interesting is when we look at these clusters, you look at them and you say, wow, that looks so far away. How come it doesn't look anything like, Messier 6 or Messier 7, the clusters we looked at earlier? Okay, it doesn't look like it because this cluster is farther away, and the stars are closely packed together. But you have to understand something. When we look at a star cluster, or we look at stars in general, one of the things you have to understand is that all stars are just points of light. Okay, all just points of light. We can't see stars in their true disk shape unless we do something fancy, use an interferometer, and look for the disks of stars. We can't see the disks of Alpha Centauri A or B, the two stars that orbit each other. And these stars are the closest to us besides our sun. And that's because the universe is so vast. But if the star happens to be of a huge diameter, then it can be like the distance of Betelgeuse. In fact, it is Betelgeuse. And we can see the actual disk of Betelgeuse. Antares that we saw before, we saw it, just visually. But this is what it was before when I photographed it for you guys before we started the stream. Antares is massive, and they can actually, with care and special techniques, they can resolve the shape of Antares and see the disc shape of it in the sky and actually in space, and they can actually see the dust that and the gases that Antares is expelling as a red giant. Just incredible how this looks, So that said, okay, when we look at the Sagittarius star cloud and we look at these other stars, okay, we could have a star that's, massive inside this cluster. In other words, most of the stars in the cluster are kind of all the same masses, but you can have some that are slightly more than others. All right. But this is really something that takes the cake, because we have some beautiful, beautiful stars in this region, and there's no doubt about it. I just love this area. Love it.
Wow.
And
Wow.
Yeah. Now, when we look at stars like this over here, okay, let me just back out a bit. Like over here, these two stars right here, those guys look like double stars, don't they? I mean, they look. Hey, look at these stars are like, they're like got to be orbiting each other, right? As double stars. In fact, that's actually just a superimposition. It says the stars are just close to each other, but they're vastly different distances from each other. Okay, one is much closer, one's much farther, and so we don't actually. That's not a true double star that's gravitationally bound. So that's what we look for. That's what we talk about when we talk about double stars. We want a star that's either a visual double, that's not a real double star, or an actual double, like Albireo and Cygnus, which is a stunning, beautiful double star. You can't say anything bad about Albireo. Don't you dare. None of you, ever.
Promise.
It's beautiful. So let's see what else we can do here. There's a few more places that we can go here. And Daryl probably knows exactly what I'm going to do. But before I do that, we're going to climb up the ladder here a little bit more and look at Measure 18. This is called the Black Swan Cluster. Measure 18. And we're going to go there now. All right. Wham! Away go the stars. And then you'll see our guide star. That is to say, our pathway star. Our pathfinder star. That's going to show up as well. As long as it's... Yeah, okay, it's going over there. There it is. And there it goes. All right. And now, the Black Swan Cluster. And now for your amusement and fun, the Black Swan Cluster, ladies and gentlemen.
You're taking the words right out of my mouth again. I was going to say enjoyment and edification, but hey, close enough.
Okay, very good. That's a better way to put it.
Oh, no.
Okay. So we are on our narrowband filter, which for we're on the wider narrowband filter, which for clusters is really not that necessary. I can drop this down to say 10,000, maybe even less, and we'll drop this down to at least 25 seconds. All right. Actually, I'll go down to 8. Okay. So now I should have my guide star. Now we'll do the Black Swan Cluster. Beautiful location in the night sky. And then we are going to head up to the Omega Nebula. Another beautiful nebula in the night sky. And then from there, we're going to go even further north to even more nebulas. Yes. I think it's going to be pretty tonight. So, this is 25 seconds. And, yeah, look at that. We got some star trails. Again, I have to just do the photo again. Because I am certain that we hit that periodic error issue. This is the star field we saw before. You know, and when you're looking at the Milky Way like this, almost everywhere you look in star fields like this, you can see hints of nebulous detail. Like there's a nebula right here. You can see it down there. It's beautiful. And here we go. So here now we have the Black Swan cluster. Look at that. Isn't that beautiful?
Oh my.
Yeah, it's really, really pretty.
Wow.
You know, as a kid and growing up, you know, learning astronomy, and most of you know this, I told you this probably to the point of like ad nauseum. When I was 9, I decided I was going to be an astronomer, and I followed through on it. And I'm 59 now. Okay? I know. Doesn't seem that way. I know I look like I'm 79, but I am only 59. And so basically, clusters like this, I could just stare at these for days. I'd say, look at those stars right there. Look at those beautiful stars. What are those doing? You know, look at these orange stars here. Look at those, you know. Again, are those foreground stars, or is the cluster old and, you know, older? And I mean, because clusters do get old and stay together, you know. So that's something that we need to pay attention to, right? But boy, that's beautiful. Daryl, you
I just wanted to give you a little boost. No, not boost. A pat here, not a pan, as they used to say in Hollywood, but a pat. We are also, I think I speak for everybody, so glad that you became an astronomer.
Oh, well, me too. Because well, thank you.
We all benefit so much by that. Wow.
Well, yeah, and my parents, when I was growing up, they said, "Why do you want to be an astronomer? Why don't you be somebody that can make some money?"
Oh.
They weren't wrong. They weren't wrong. I mean, you don't make a lot of money as an astronomer, and your reward for it is you spend the night in in the early days you spent the night in dark domes that were frigid. My work that I did in astronomy was studying nearby stars, parallax studies. Then my thesis was on B-type stars, stars like the stars in the Pleiades. They were racing out of our galaxy at high speed, and I found a number of them. I found a bunch of them. So they actually did. It did mean something to me. It did work out for me, in astronomy. But I always wanted to take my astronomy to a different place, and that place was that I wanted to take it to everybody, because I thought, just because people don't understand the sky, or because the sky is inaccessible because it's the city, they don't get to see all these stars. It's like, I have seen the faces of inner city kids when I taught overnight groups. I had groups literally of 40 people, and I was the only one taking care of them. And I spent the night showing them cool things with the telescope, giving them really cool things to do. And they spent a lot of time looking up for the first time in their lives. And They saw dark sky, and they saw objects in the sky that they had never seen before. When you see that light, and Daryl knows about this, he's talked about this when he's done for many years he's done this. The guy is amazing. He's done this public outreach stuff like I have. And when you look into the face of someone who sees something for the first time, let's be simple, Saturn's rings, okay? For the first time they see Saturn's rings, and they are just stunned into silence. Daryl has a story that he's told about some of his more interesting experience he's had. Daryl, do you want to relay one of those? I remember one in particular that you've said in the past.
Oh, I could think of a couple. Saturn's rings. I was doing a star party down in the mountains one summer evening a long time ago, and there was a young teenage girl. Uh, I had a line of maybe 50 people at one of the telescopes, and she would wait patiently her turn, and she would get to the telescope, and it was a refractor, and I had it pointed at Saturn, and she just could not get enough of it. She would ooh and ah, and just exclaim how wonderful it was. And the person behind her would finally convince her to, give up the telescope so they could take a look. She would immediately run back to the end of the line and go through it again. She must have done it half a dozen times.
Yeah.
It just tickled me. I've had people accuse me of putting a picture of Saturn in the telescope. They couldn't believe, that what they were really looking at was real.
Yeah.
And that's life-changing. I think that makes an impact.
Yeah.
Forever. Yeah.
I mean,
it does.
And I think both Daryl and I have had people that have looked through the scopes we were marshaling for people to look through. And I think we both had people that looked at something for the first time in their lives and cried.
Yep.
Oh.
Yeah.
I had an elderly lady. Jupiter was over in the west soon after sunset. The seeing was not great. It was about to go away. And I had a chair she could sit in. She sat down and looked at Jupiter. You can see the two big bands look like tire tracks across the planet, and see the four moons to the other side, and she was brought to tears. Yeah. She had just never seen anything like that, and it made her cry.
Yeah.
Wow.
I remember there was someone I showed the Orion Nebula to, and what's embarrassing about it is that it was a nighttime session that I was running, and the person that was looking through the telescope was actually the teacher of the students.
Oh my.
Yeah, and he started crying.
And, oh my.
Yeah, I mean, when you've got kids of that age, this is very uncomfortable for kids. It's awkward for children to see an adult cry. So he kind of got very emotional looking at the Orion Nebula. Couldn't believe what he was seeing. Asked a bunch of questions, and then just sat down and started sobbing. And I said, "You okay?" He says, yeah. "I have never seen anything that beautiful before. I didn't realize the universe has this up there for And I'm like, "Oh yeah, it does." And I said, "You better drink some water because you're gonna have to stay hydrated because you're gonna be crying a lot more. I got a lot more things to show you, And yeah, but he that was sort of awkward for kind of all of us. But you know what? Awkward, yes, but realistic, as well. It's exactly what I've seen.
It brings out honest emotion in people
really
sometimes.
Does.
I mean, they're just really overwhelmed.
This here on our screen, this is the Omega Nebula. This nebula is and I say it this way, this is a former star-forming region, because now the Omega Nebula has actually, as far as we can tell, has ceased star formation. There's not a lot going on anymore in this nebula, but what's left is this glow that we're seeing. This glow is coming from stars that are buried inside the nebula that we don't see. This area here, okay, this is actually like a little bay, but it's not a bay per se. It's not a lack of gas in there. It's an object that's overlaying a brighter nebula behind. This is a dark nebula here that's overlaying the brighter nebula behind it. Behind it over out here. So this is up front. This is way in the back. Okay, so that's really how that's working, and it's kind of a cool thing to see. We see that more obviously with the Orion Nebula, and we might be able to show that a little better if I can just take one more shot of it. This was 30 seconds at 12,800. I'm going to go to a minute. Okay. And even go up another 2 stops. All right. I'll go to 20,000 for 1 minute. All right. And now let's take that picture, and then we'll come back here now. So this is the Omega Nebula, known as Messier 17. And it's reddish, again, because of the fact that we're looking at this ionized hydrogen gas. Hydrogen only has one proton and one electron. And if that electron gets energy from a nearby star, it'll bounce right off that off that hydrogen atom and head out into the gas where there's other hydrogen atoms that have similarly been ionized like this. And when it loses enough energy from collisions with other objects out there, it will fall back into the atom. And as I said earlier, to that state called N equals 2. And there's many states in a hydrogen atom, and that 2 is the predominant one that these fall to. And when that happens, when it gives up this energy to fall back into a known state, wow. Sorry. When it gives up this energy to fall back into a known state, what happens is it gives off light. And this is that light. It's this beautiful reddish light of hydrogen alpha. And now you can actually see that this is actually something that's kind of like a tongue of black dust that's overlying a brighter nebula behind it. See? You know? Yeah, and it's a mixture because, you know, the way we're taking this photograph, it's sort of a mix of things going on in here. But you can clearly see some dark stuff here overlaying. You see dark stuff here overlaying. And this is a really pretty shot there, Daryl. You know, it's a nice shot of the image.
It is.
And this is the narrow band, the full narrow band filter. So I'm just going to try something absolutely crazy. Now, the fact is the moon is up now, so anytime you do a shot like this, you run the risk of the moonlight interfering. But when you're using a narrow band filter like we are now, the narrow band filter will actually prevent the moonlight from causing any problems, and we could probably do this. We'll try this 2-minute shot here just to see what happens. And I told you I don't want to go more than a minute typically, but you know what? I gotta just try this on this because it's really looking pretty. So
you're a wild and crazy guy.
Because we're the wild and crazy guys. Steve Martin, remember that? On Saturday Night Live. Yes, sirree. Yeah, so that's the Omega Nebula. And this is with the narrowband filter. The narrowband filter, as I said, slots within the spectrum. It only pulls out that hydrogen alpha stuff. It pulls out the O3 stuff. It pulls out the sulfur 2 stuff. Okay, so those 3 narrow bands are what this filter is giving us all at once. And that makes up the bulk of the detail in the nebula. And when I say detail, I ain't kidding. Okay, when you look at this nebula, right, and you look like right here, okay, look at all this stuff, this convoluted stuff in here. This is really interesting, interesting to me because we're seeing all kinds of knots and filamentary structures in here. It's like looking at an extremely complex 3D shape. And this nebula is in 3D. It's not projected on a flat surface, right? So it is 3-dimensional. And we actually will go into on our indoor streams when it's raining out or whatever. We run another program where I actually go into the nebulas and spin them around, and then you can circle like the Pleiades and see the blue reflection nebula and the Pleiades from all these different angles, and see how it looks from the other side, or from the left, or from the right. It's very cool, how we can do that, and that's courtesy of a program called Space Engine. I have the pay version because it's got more detail in it, but it's worth every penny, especially if you do what I do. All right. Okay. Oh man, come on. Where'd it go? Yeah, that sometimes happens. I'm working with a company. This is my remote access software to the observatory. Well, there we are. It's back. And this is the... Wow. That is the 2-minute shot. Isn't that pretty? Now you can see even more detail up in here. That is amazing. What a beautiful, beautiful nebula this is.
And the dark cloud just seems to get darker.
That's right.
Yeah.
That's right. In fact, that's a very good point, Daryl. I want to point that out. If you compare the space, this empty space here with that dark cloud, okay, it's really not that much darker than this space at all. That's sort of an illusion. If I were to zoom in, okay, I know this looks really noisy in here, but we are taking a noisy pic. You can see that this brightness is the same brightness as this, but you're also, you know, subject to that illusion that it makes the bright stuff around it makes the center look darker. But it does have a lot of really interesting detail in this nebula. I think it's just phenomenal, just fantastic. So what we're going to do now is we're going to go to the next object. The Price is Right. The next item.
May I answer David Schmidt's question? He labels it to you.
Okay, read the question, whatever it is, first, so people know.
Why can the reflected light from that pinkish nebula not shine through that darker one in front of it if the darker one has nothing that we can see to block the light? David, it's just like pulling a shade on a window because the sun's shining through it. Sun ain't going to get through that shade. This is like the Barnard objects I talked about when Mark went out to move the dome earlier. I mean, it's a cloud of dust, and it's thick enough that visible light will not come through it.
Yeah, it obscures.
That's why, as Mark said, that's why we look at those dark clouds with infrared telescopes instead, because they can see the heat or the warmth coming from the objects.
Inside the dark clouds. And we've seen protostars forming. There's very, very young stars called T-Tauri stars that are within many of these globules. Named for a guy named astronomer called Bart Bach. And I was actually fortunate enough to meet and talk with Bart Bach, and he was at my university actually when I was getting my degree, and he was one of our professors for a while, and it was actually really cool to meet with him and listen to the man who discovered these globules that have forming stars and possibly even other stellar systems in them. Amazing guy. But you know what? In general, all astronomers are disheveled and kind of their shirts are untucked. You know, who are we impressing? You know? Yeah. So as Daryl said, Dave, this stuff is obscuring dust that will block the light that's coming through. Seen really clearly in things like the Orion Nebula. More believably seen like with this little area here, okay, on this particular nebula, or these dark areas here. This stuff is little tiny dust molecules, and they're strung together molecules. We could be looking at carbon atoms strung together along with other materials to form dust. We could be looking at, depending on what other stars contributed to this, we could be looking at other types of molecules. But in general, they form these weird little spindles. They're kind of like spindly shape, which I think is interesting considering how Oumuamua looked to us. Oumuamua looked somewhat like a spindle shape as well to us, you know. So I find it fascinating that the spindle seems to be kind of a universal constant out there, you know, and it's pretty cool. I do want to get to another object here as well. And I want to go here now. So you'll see we're going to head off there now, and we're heading to the Pillars of Creation.
Oh, one of my faves.
Yes, the Pillars of Creation are beautiful. Did I actually get it or no? I can't tell if I... Okay, yep. So we're there, and... okay. Maybe the dome's in the way. let me go back here and yeah, see it. That's not the. I would recognize the eagle if it was here. Okay, so if we go like this, let me just check it out. Yeah, I don't see the eagle here. Actually, you know what I'm going to do? I'm just going to take a quick shot and just make sure we don't have clouds. 10 seconds. Because we could have clouds.
Yep.
Yeah. Okay, it is the eagle, but we apparently either have clouds or the dome's in the way. So, would you allow me to go check?
No, I think you have to stay right where. Yes, of course. Go check.
All right.
Go check.
Daryl, entertain the troops with Carol, and I'll be right back. All right.
Very good.
I've got some backfill if we can. If everybody remembers what you were talking and looking at the trifid, and then there were the trifid jokes. Way back when I was just, I was a newbie in musical theater, and I was very lucky to get cast in a tour of the United States and parts of Canada. And one of the people who would fill in periodically playing the lead, we had several different people, for 6 weeks here, 6 weeks there. It was a 6-month tour. One of them was none other than Howard Keel, who is the star of Day of the Triffids. And a real cool guy. It was kind of funny though, because he was used to film acting, yet at an entirely different pacing. And we sort of would roll our eyes because we could count on, the show lasting like 20 minutes longer a night, and at that point we just kind of like wanted to get back to the hotels, etc. But he told us some interesting stuff, that the scene in the lighthouse with a couple of, what were they, biologists, and the saltwater stuff, that was actually filmed later and inserted because production felt like the film was a little static. So that was an afterthought.
Huh.
Yeah, which was kind of wild. It's so nicely integrated, into the rest of the movie.
Mm-hmm.
But, yeah. Crazy. That's Hollywood for you,
Yep.
And the image we're looking at now, I keep seeing a fish. I see a fish tail and kind of a fish body and a fish head. You see what I'm talking about there, Daryl?
I do.
Yeah.
I've said before that when I look at the Omega Nebula, I see a duck decoy standing on its head.
That's great.
The head is to the lower right and the belly is to the upper left. It's like you took a duck decoy off a table and it's perched on its tail and its head.
I can kind of... thanks, Mark. Oh, there we go. Yeah, wow, okay.
They call it the Omega Nebula because I guess it got its name back when scientists were still classically trained, and you'd have to rotate it back to its usual orientation. They thought it looked like the Greek letter omega, which is sort of a humpback shape. Right.
And then, of course, a wonderful embedded thing in that is, okay, listen, this is talk about wild and crazy. The omega-3 oil and fish, well, never mind. But I just had to throw that in there.
Yeah.
Well, okay. As I
when I see it, I think of the duck decoy cluster, or the duck decoy nebula.
Yep.
Maybe you can petition and get it renamed. There's a lot of that going on right now.
It absolutely is. All right, we're going to go up to do 30 seconds, and I'm going to reduce this from this really, really high value down to something reasonable at 10,000. No, I'll do 12,800 for 30 seconds. Okay, we will not have the dome in the way as we did moments ago. Yeah, this is going to be good. What we're going to see here is the pillars of creation with the narrow band filter. And that means we're going to see a lot of detail in those pillars, we think. This narrowband filter doesn't get used often enough because in the Connecticut skies, I would have to take much longer exposures than I will have to in... Oh, wait, that ain't it. That is it, isn't it? I just didn't take a long enough exposure. There they are. Yeah, okay. Not as exciting as we had hoped. So what I'll have to do is I will go to filter number 2. And I still don't see... Is this in the right spot? Well, it claims to be in the right spot. Well, I'll do another shot just to see. We'll see. We'll see. I mean, we're seeing the nebula detail here. I think I see a nebula there. Do you see that, Daryl?
Maybe.
Well, that's a non-committal. No, I don't. But you're right.
It was meant to be.
Because you can't commit to seeing it. Yeah, me either. Yeah, what's going on here? What?
Are there clouds?
Yes, there are. But I didn't expect it to be so difficult to see. I was hoping I could see. We have some light clouds that have moved in, yes. Unfortunately. So I didn't see exactly... Let's see all this build up to this, and here it is. You know, it's like... well, let's try something else. Because I didn't like that that's doing that to us.
There's the wild duck cluster.
That's where I'm going.
Talk about duck decoys. That's M11.
Yep.
In Scutum, if I remember right.
And the nice thing about this particular cluster is that it's a gorgeous cluster that looks just like it could be a globular cluster in a sense, but it's not. It's not a globular cluster. Okay, and we're actually going to Talman Prior as our guide star. I should say our pathfinder star, and then we're going to head down to the wild duck right here. And the wild duck is a really interesting cluster. Alright, so we'll see Talman disappear here momentarily. There it goes. And more stars go whipping by until we get to the wild duck. And we'll let it center it up, let it then find its guide star, and then we will be able to actually see what this cluster looks like. It's gorgeous. There is a cluster called the Santa's Sleigh cluster.
Really?
Yeah.
Oh, jingle bells.
Well, now I gotta see that. Okay. All right, let's do... we're gonna do 20 seconds at 8,000 here. The sky background is gonna be a little bit purple because the moon has risen higher in the sky, but not high enough to be of any good viewing consequence. So, all right. So we're just doing a 20-second shot here. Yeah, there's M11. What a beautiful cluster. It looks like it's in the process of having a little guide error. So we're going to fix that by just doing it again. Okay. Now, Daryl, I'm going to ask you, where in the world do you see anything wild duck associated with this cluster?
Good question. I was thinking that earlier.
Because I don't.
I think the story goes, whoever named it, It reminded them of a flock of wild ducks flying through the sky.
A flock.
I've heard you say that. I've heard you say that, and I guess it could be that.
But ducks tend to fly in V's. Do you see a V in any of that?
No.
No.
We know geese certainly fly in V's as well. Well, hey,
it's
a
an aerodynamic thing.
Yeah. And you're right. And in fact, the lead goose in the V is really the one that's expending most of the energy, and the ones to the side are actually less impacted. So over time, when the first one gets tired and he drops back, somebody else takes the lead. I don't think it's a conscious decision, but at least they don't do the same thing that starlings do. They do that, what's called that murmuration.
Oh, yeah,
which
has been photographed, and it's like, what's that in the sky? Right,
right. I got those as UFO reports. And what's this odd thing? It's coming toward us. I'm afraid for my life. It's like, well, only be afraid if they kind of go to the bathroom on your head,
Hey, listen, I could tell a story.
I think you should.
I was a little kid. I was riding my bicycle up the street, and here came a huge flock of starlings flying overhead. And it was a really, really big flock of starlings, and I noticed it was like it was raining all around me. And then I realized, oh God, that's not rain. That's starlings, doing their thing up in the sky while they fly over me. Mm-hmm. And
so you pedaled faster, right?
Didn't do any good though.
Oh.
Now he just got more like flat in his face,
Right.
I was like, ah.
Oh, great sound effect.
Yeah, sure. I remember walking outside. I was on my way. I think I was going. I think I was supposed to go out on a date, and I was in high school. I looked really good for all the time I took to get myself set up, right? And as I'm walking out of my house, I walk under my big maple tree out front, and I feel somebody tap me on top of my head. It's like a little tap. I went, what? I look up, I don't see anybody. I'm like, well, somebody. I look behind me, is that my sister? I reach up on top, and it's wet.
Ew.
And I realize, I pull it down, like, oh my gosh. So I didn't have time to go in and like wash my hair again, and all that. So I went on the date. And as the night wore on, it started drying out up there. And it became really crusty and would flake off. And needless to say, it did not go well. Yeah, it didn't go well.
Not a good hairdressing, no.
No, definitely not. I'm just trying to get a couple of things, trying to get another couple of photos.
It's very red stars in that image.
Yeah, well, we are, exactly, but we are using the filter too.
Ah, okay.
So we do have that issue.
Well, some of them sure are red, though.
Yeah, they are.
Some are, some aren't. Two over on the far right, several inside the cluster.
Yeah. Okay, I see that's wrong here. The temperature changes slightly outside, and when it does, we end up having to... We have to be careful about the focus. The focus can change. And it has. So I'm going to bring a star for focus right in here. So one moment as we do that. There's the pair I want to focus on. Okay. Now we'll focus. Okay, they're out of focus. They're right on the verge of visibility, and then when you get them focused, they become much sharper.
Carol, your Howard Keel story
Yes.
earlier reminded me. Are you familiar with the movie Plan 9 from Outer Space?
Oh, I
gosh,
certainly
yes.
am. Oh my.
Yeah. That was Bela Lugosi's last movie. You know, the guy who played the classic Dracula back in
Oh,
1931 or whatever.
He
Yep,
died
yep,
during that
yep.
movie.
And what a vampire is doing in a cheap science fiction movie, I have no idea. But they
Oh
dressed.
gosh, I think he was trying to pay the rent at that point, you know.
Well, yeah, sure. Anyway, that was his last movie, and he died during the course of the film. And the film was directed by, oh God, I can't think of his name. His last name was Wood.
Yeah, yes, yes.
Oh, yes.
Yeah,
That
yeah.
famous Frank Wood?
Edward.
Edward,
Yeah,
Edward.
I think
Yeah,
you're right.
yeah.
Well, Bela Lugosi died in the course of the film, and they needed a stand-in for him, so they brought in some guy. I don't remember who he was. He was just some guy. He didn't look anything like Bela Lugosi.
That's right.
They dressed him up in the outfit, and his hair was totally different. He was a lot skinnier, and face was shaped different. And Ed Wood told the guy, just hold the cape up draped over your arm in front of your face, and people will never know the difference.
So that's the backstory as to why we never, after a certain point, we never see his face.
Exactly.
I'll be darned, I didn't know that.
And
that was Ed Wood filmmaking for you.
Yeah,
exactly.
why, and it was why in other Dracula movies, Forevermore, they mimicked that for a different reason, because he would actually hold it in front of his face because he was, I don't know, being mysterious or something, but in fact it was to hide the identity of the non-Lugosi actor. But they did it.
Wow.
They did it anyway. They did it later on they filmed that way anyway, but they shouldn't have. Here's
so that was
focus.
It became a character trait
Yes.
of Dracula. Ah, wow! Now it's all making sense.
Yep.
Is there a satellite in that image?
Exactly. That's where I'm going to show you this. See this little line right here? That's a. That's a satellite that's actually going through the image. Okay. And what we can do actually, which I don't want to necessarily do tonight. I actually wanted to share something else, but I gotta figure out what I'm doing here for a second. Okay. Yeah, that's a satellite that's going through the image right there. Right there. Yeah, and you can see the trail of it right there. What you can do is you can actually measure the length of this and calculate its length in what's called arc minutes. And from that and the time of the exposure that it took, the length of the exposure, we can actually calculate its actual altitude, where it is. I wrote a program to do that, and we can actually figure out whether this is a satellite that's at 200 miles, 400 miles, 600 miles. Is it a rocket body that was doing a transfer orbit to geostationary orbit objects 22,000 miles out? Okay, if it was a geostationary, it wouldn't do this, so it wouldn't be a geostationary, but it would actually be. It might actually show, depending on the length of our exposure, and our exposure here was 25 seconds. So usually, when you do like 1 minute exposures, you might get little dashed lines that show up in your final image that are maybe only this big. And those little dashed lines are actually the geosynchronous satellites that, geostationary birds that show up because we're guiding on the stars, and they're hovering over the same spot on the Earth. Well, the stars aren't. They're rotating and moving with the rotation of the Earth, but the satellites don't. The geostationaries don't. So we'll see a little dashed line of a geostationary satellite showing up, and they're usually about this faint. But this is a little bit too bright, I think, for geostationary, and definitely the path is too long for 25 seconds. That's actually moving across this way toward the east, because this is west over here and this is east over here, so it's moving toward the east, right? And I know that because most satellites go from west to east. Okay, but this is a beautiful. I just love how this looks. It's really pretty, and you can see, as Daryl pointed out earlier, the colors.
Yeah.
In some of these stars, when they're very different under the filters, they show really, really dramatically different sometimes. Really pretty. Now, how come M11 is here and M16 didn't show up? You know, why would the Pillars of Creation not show up? Maybe because it's, I don't know. I don't know why it's not showing up. It should have shown up. All right. Well, we're gonna actually see if we can do this again. I want to go to the Eagle Nebula again and see if we can grab it. Okay, no, I know where we are. That's fine. Thank you very much. Move along. Nothing to see here. And away we go. Okay. Stars whipping through the field look like streaks, as you can see. Let's see if we can get to this star. Okay, so now we got the star coming in. We didn't have that before. This star did not show up. So it must have been that we had some clouds. Yep, we had some clouds. Yeah, see, that's the Eagle. How do I know? Trust me, I recognize the cluster. All right. Okay, so we're gonna go and put us into this mode here. All right, we should have our guide star by now. And we're gonna go 25 seconds at 8,000 seems okay for me. Here we go. And we're gonna come back over here. And we'll be able to see the Pillars of Creation show up here. Indeed. Okay, there we go. Okay, the Pillars of Creation are here. You can see 1, 2, 3. Right, and with the moon out, this nebulae are quickly becoming less visible. So let me try going all the way to a minute at, we'll leave it at 8,000. All right. So, you know, the Hubble Space Telescope is famous, and of course, it took a beautiful picture of these pillars of creation. What are these pillars? These pillars are actually gigantic, light years long strands, big thick columns of dust and dark nebula. Dark nebula, you know, gas is transparent, no matter what kind it is, really. Except for certain kinds, you know, like bromium is a brownish gas. You can visually see it. But hydrogen and the gases in the interstellar medium are generally transparent. But it's dust that actually is the culprit for, in a lot of these cases here, where we're seeing, you know, these dark objects in the sky and the shapes like this. There's some dark nebula inside this area right here, and after this exposure, we'll be able to see that a little better.
Do we have any idea when the Pillars of Creation got their name, or who bestowed that upon them?
It was when the Hubble Space Telescope took the image. They,
it wasn't until then. No, I didn't know that.
Well, because, see, this was M16, the Eagle Nebula.
Yeah.
Okay, and it was never... The feature called the Pillars of Creation inside was something that was always... they were always there, but they were only labeled as such when the Hubble deep sky shot of the pillars alone just took by storm the view, took by storm everybody's mind, you know, when they saw
Yeah.
this thing. It was beautiful. Just beautiful. Well, got a little guiding mishap there, but you can see the pillars a little clearer there, but
Right.
I gotta do this one more time, and we're gonna hopefully have a better shot. Yeah, these are beautiful, you know. So basically, you know, we're looking at these dark pillars here. This is the main pillar here. And this area here, I took a photo one night here where you can actually see strands of gas coming off this thing. Okay. Oh yeah, it was just stunning. Daryl, were you with me that night when we were doing that? I think you were.
I believe I was, yes.
And I think that was the night I took a picture of the Veil Nebula. And I literally was beside myself because it was the first time I had ever seen the Veil in my life. It was through the SkyTour LiveStream telescope. Yeah, and the Veil is a supernova remnant, and it's distended, it's expanded out, and it was just stunning. Oh, stunning. You know. Yep. Yeah. So tonight, what's that?
That was when I sent you my O3 filter.
That's right.
I think when you saw it, though, you were actually using that other O3 filter you got.
Yeah, actually, it wasn't even an O3 filter. I was just using a Sky Glow filter, which is a generic filter, you know, for trying to remove some of the sodium vapor.
I remember that. Yeah.
Yeah. Yeah. Okay, this is the bad one, so we're waiting for the next one to come in. Let's see if we are still taking the picture. Okay. Oh, we're doing 2 minutes, aren't we? Oh, I went to 2 minutes. Oh, sorry. I thought it was 1 minute. And we can see that the guide telescope probably isn't able to see right now because of that we might have the yeah, it's probably having a problem with the dome. That happens sometimes, and I tell you, it's maddening, but it happens. Won't ever happen again though. Once it's a roll-off roof. I am going to do that. I cannot wait to put them.
Oh yeah.
Oh, I'm gonna replace this with a little shed that has a beautiful roll-off roof, and then I can do all the things I want, make it automated, and then the one that goes out into Arizona is automatically going to be automated. We should have that all done this trip. We're going to have the observatory built. We're going to have the roof built. We're going to have the extension rails that come off the building that are going to hold the roof that slides off. And then we're going to have the pillars that go into the ground. Not the pillars of creation, but the pillars of, the pillars of the roof that will actually support the roof when it's at its full extension off of the building. You know?
And we're hoping that you'll be sending and posting a lot of video of all that.
I will be, actually.
Okay.
Yep. And the other thing too, just so you guys know, I mentioned how we're going to have 2 piers in there and possibly a third. Well, one pier is going to be the SkyTour LiveStream telescope that we're going to put out there. And that'll be a second observatory to go with the first one that will still be active here. And then the second pier is a pier that has already been rented by another group that does streams, astronomical streams.
Sweet.
So we're going to have a building is going to be doing 2 sets of streams.
Wow.
You know? And then the third pier is going to be for the high-end astrograph when I get it. And I'm looking for support of a foundation, maybe, to provide assistance financially for the public outreach we do. So that's what's going on. And
oh, that rocks. That's really exciting.
yeah, I just have to make it happen. You know,
you will.
The funding part.
Yeah.
Yeah.
Well, you know, your body of work just sort of speaks for itself. I can't imagine that you'll have trouble finding somebody or some institution, right?
I hope I don't.
I think you're going to need a bigger observatory.
Well, you know what? That's
3 scopes and a 12 by 12. That's going to get crowded in there.
Well, but the thing is, it's a roll-off roof, and I set it up so that the when the roof is rolled off, every one of the scopes is going to have a view almost down to 10 to 15 degrees above the horizon. I worked it out so we can do that.
Wow.
Yeah. There we go. There's some pillars.
Oh, yeah.
Okay, see the one. And Daryl, you're right. I mean, there's nothing wrong with adding another building out there, you know, especially after the first one. You know, I saw some of these other roll-off roof buildings. They were just huge. They were like 40 by 40, and this gigantic truss roof would roll off, and then there was one telescope in there that was small. But there was room for like 30 other telescopes, or 20, not 30, but about 10 other telescopes. So I thought that was pretty cool.
Or one great big telescope.
Yeah, one big one. Yeah.
I was looking today, a guy designed and built a roll-off observatory.
Mm-hmm.
I think it was 8 by 10, he said, and he had 2 telescopes in there, and it looked like it was darn crowded.
Yeah.
But he said he had enough, swing through for both of them.
There he is.
Yeah.
What I always think when you talk about the observatory in the desert, I think of Bud, Dave Carradine's brother in the movie Kill Bill.
Oh, really?
Living in a trailer out in the desert someplace.
Okay.
You know, just becoming a desert rat.
Well, I don't know about desert rats.
You intend to move down there someday?
Yes.
Yeah.
Yeah.
There you go.
I've already got. I probably have more friends in Arizona than I have in Connecticut now.
Mm.
Yeah. I mean, you know, here's Arizona life. You go down there and you want to, talk to people, you make friends. If you find yourself at a point where people are very friendly with you, and you do things for them, and they do things for you, they will extend themselves to you and say, hey, look, when you come out here, you just call me and you stay here. I haven't had a hotel room out there in probably, I'd say 5-8 years. And that's because every time I go, I'm not effectively allowed to stay in a hotel room. I'm going to stay with someone here, someone there. And it's all because the people out there that I have met so far are very kind, genuine, warm people. See, one of them is right here in the chat now, Tara. Tara's here.
Tara, yay.
She's a very genuine and kind human being, and she lives in the Phoenix area. And most of these people met me through the Mutual UFO network stuff that I've done, teaching and boot camps and stuff, which I'll be teaching in the November class again as well, which is wonderful, and I thank them. And you get no choice when you go. They do everything for you. It's like, that's the way they are. It's very kind. They're
Arizona hospitality.
Yeah, and you think, wow, that's pretty crazy. In a state that has, deadly animals and things, you would think that people would be kind of skittish about, you know, people in general, but not been my experience. You know, if you're their friend, there's nothing you can do wrong. Well, maybe, you mean don't steal cars or anything, but whatever. But if they're your friend, you can do no wrong. But if you're on their bad side, I would hate to be there too, because Arizona's an open carry state.
Ooh.
Yeah.
Yeah, that's called the 3 S's. Shoot, shovel, and shut up.
Oh, in that order.
Yeah. Well.
But no, I know what you're saying, and I think that's more typical for Westerners than, not to sound prejudiced, but Easterners. You know, once you get to know them, I know some places out here, like up in Wyoming, I've heard it said that, you know, people from Wyoming, they're very independent, and they don't much cotton to strangers, though. And you can move to Wyoming, and when you get there, you will be considered an outsider. You can live there for 50 years, and you'll still be that outsider that moved there 50 years ago.
Yeah.
But that's Wyoming for you. All the West is being flooded with people moving there now, and I know a lot of people, long-timers or natives, you know, they kind of resent how bad it's become. Colorado's getting to be like that. Colorado's being loved to death.
You see what Marianne,
seriously.
Yeah, Marianne, you know, what do you mean we do everything for you? You'll be doing everything. That's Marianne.
Yeah, that's Marianne. Wow.
Yeah, and when I say that, Marianne has done more for SkyTour LiveStream West than anybody else. So I think she's being kind of funny about that.
Read farther down and read her suggestion.
Yeah, I don't want to I don't want to catch a rattlesnake. I want to eat them. Okay, they're the best eaten. I've never had better tasting food than a broiled rattlesnake slathered in butter. Oh my gosh, it's so good. I ate the whole thing. I'll be honest, it was a 4-foot long snake, and I must have gained 5 pounds that night because I just ate every bit of it. I could not believe how good it was. And on top of that, there was alligator as well at this same dinner. And when I asked the guy, his name is Kevin, the cook, I asked him, you know, where's all the snake go? He said to me, he goes, you're the only one that's been eating it. As soon as people found out it was rattlesnake, they won't get anywhere near it. I'm like, oh my gosh, they're lost. You know, they're lost. So I ate it. Asked him for the rattle, and he goes, oh, this woman over here asked for it. Did she have any of the snake? Well, no, she just wanted the rattle. I go, that's not fair.
Yeah, exactly.
That's okay. And then the alligator tail was also there. And I could not believe how good that was. Oh. You think alligators must taste like mud, right? You know, it's like, no, it does not taste like mud. It's like the same way that lobsters don't taste like mud, you know, and the dead stuff they eat, not at all. So it's really, really good. And alligator does not taste like lobster, but it does have an interesting flavor all its own, just like rattlesnake. Rattlesnake is sort of like flaky fish in a sense. It kind of looks like a flaky fish, but it doesn't taste anything like fish.
Tastes like chicken.
And you know what? No, it doesn't. That's the other thing too. You know, it doesn't. It tastes like its own thing, and that's the problem. You don't know. You know. I'm trying.
I'll take your word for it.
Oh, come on! You're not gonna try it?
Nope.
Well, that's
listen.
pretty
I grew up on the wrong side of the tracks down in the Ozarks, And we ate pretty low on the hog sometimes. I've eaten stuff that I have no desire to ever try again. I got invited by some roper dopers down there once to attend a raccoon roast. And I had to decline that. You know, frog legs were the least of it. Squirrel stew. A lot of it was sort of like the food they ate on the Beverly Hillbillies. Stuff that Granny cooked.
Okay.
Some of it was pretty sketchy stuff.
Marianne, you hear that? You hear what Daryl just said about squirrel stew? Okay, now you know my feelings about squirrel stew, okay? There you go. So, nothing, no, I don't want any of that rodent meat. I'm sorry, what can I say?
And they're so cute.
Yeah. Because you mentioned that squirrel stew, Daryl. Oh, that's a much better one. Look at that. And Marianne actually made squirrel stew, and she'll tell you that it was squirrel stew is good for who, you know? Yeah. No, I'm not a hunter. You know, I don't kill things. I don't like killing things, actually. You know, I don't kill spiders. You know, I put them outside. The only thing I kill.
Oh, yep, me too.
The only thing I kill is hornets and bees. You know, because they're just mad all the time. They're always angry.
Yeah.
If I can make friends,
permanently pissed off. Right?
If I can make friends with a bald-faced hornet, then I will feel that I've accomplished something. But I've just never been able to make friends with bald-faced hornets. They're just not pleasant creatures.
Yeah, you can't have a back and forth with them at all.
I got stung by a tarantula hawk wasp once when I was about 6 years old.
Oh, those are ugly creatures.
I don't even know what that is.
It's a great big black wasp. I mean, it's the biggest darn wasp I ever saw in my life. They hunt and kill tarantulas and lay their eggs in them.
Yeah. Which doesn't kill the tarantula, it just paralyzes it and makes it live food for its babies. Ugh.
Right. And
zombie spider.
The thing actually left a scar on my wrist where it stung me.
Whoa.
Well, you were
little.
It
was huge, and it hurt too.
I believe it. Yeah, I believe it.
Mark, Carol, I hope you folks will excuse me for tonight, please. I'm running out of steam here.
All right, Daryl. Well, thank you for coming along.
Tonight.
Well, you just need to have somebody shovel more coal in and make more steam, but I get it. Yeah, it was so fun hanging out with you, Daryl.
Yeah, it was
Same here.
Daryl, thank you for coming.
You all, well, sure. Thank you for having me.
Of course.
And I wish you all a good night, and everybody in chat, good night, and take care and have fun, and be talking soon.
All right, Daryl.
Good night. Have great dreams.
You all take care.
All right, see you later, Daryl. Thank you.
Good night. Yep.
Well, I no longer take, if a spider resembles a black widow spider, it does not get to go back outside. I was actually about 5 years ago bitten twice by a black widow. I woke up to the bites and I couldn't quite identify what they were. Did a bunch of searches online. But the most amazing thing was it affected my muscles. It was like, it was like childbirth. It was like an incredible pain.
Neurotoxin.
Yeah.
Wow.
So they're bad.
Yeah. Okay, so I've never been bit by a brown recluse, or I've never been bitten by a brown recluse or a black widow. And
yeah.
I'm okay with that, thank you.
Yeah. not a good experience, no.
Yeah, I'm not. No, right. Thanks. No, thanks. Yeah. Okay, we're gonna go to this other cluster here. And check it out. We're going to go to our Pathfinder star, which in this case, this is Mesher 26, okay, otherwise known as NGC 6694. This is a cluster that's about 5,000 light years away. And it's right in the Milky Way, and it should look beautiful amongst the stars in the background. So let's hope that it does. All right, so the star is being aligned up there. And then once it's aligned, boom, it's going to go away. Okay, and hopefully it... Yeah, so then we should be down here at M26 right now. And we have pulled into the M26 neighborhood, ladies and gentlemen. And we shall be disembarking shortly.
Hope you enjoyed your ride.
Hope you enjoyed your ride here on SkyTour Airways. Or Spaceways. SkyTour Spaceways.
Right, that's it.
Yeah, and we'll just do a 25-second shot at 10,000. No, 8,000. And see. I assume we should have our guide star by now. And away we go.
It's okay, we're buckled up.
Yeah. Terry Groff, thanks, man, for coming out. I realize you're calling it a night. Really enjoyed having you here the entire session. It was really good to see you, man. Terry Groff's a good friend of mine from Texas. And he is well known within the Mutual UFO Network circles. And an incredible guy. All right, so here we are. This is Measure 26 right here. This wonderful little cluster. It's beautiful. And I only did a 25-second shot. And I will do one just... I'll go up on 2 counts here. 25 seconds. We'll go to 30 seconds. And we'll go up by 1 stop. So we'll go up 2 stops to pick out a few more of the stars. And here we go.
While you're doing that, I'm going to read David Schmidt's comment. He says, Mark, that is about the 4th time tonight I thought a word and then you spoke it. To which farther down, Tara replies, quantum entanglement.
At the brainular level.
Brainular. Great word. Best word.
Yep. At the brainular level, I say it. Yeah. We're all very much on the same sets of wavelengths.
Oh, yeah.
And we can sense each other's thoughts, too. Yeah, look at that. See, now you can see a little bit more of the complexity of the stars in here. This is sitting amid a lot of other stars. And it's a young cluster of beautiful stars here. And I can tell you that it's just really so... It's really quite beautiful. It's perfect music for looking at clusters.
Yeah, I was just thinking that.
Quantum entanglement.
There we go.
Yeah.
Quantum entanglement dollars at work for you.
That's funny. That's right. Yeah, so, I mean, when I look at clusters like this, I can't help but think. Okay, let's just look at it up close for one moment. I can't help but think. Are we looking at a future star system that has worlds around it? Maybe with life. These stars have been here for a while. So it's possible that these no longer have... They were born in a nebula at one point. A nebula of gas and dust. But their stellar winds blew that all away over time. So this is a mature cluster that's sitting there. And is it possible that there are planets around some of these stars? The answer is absolutely yes. We don't know for sure unless I can look up the Kepler and test data to see whether the Kepler Space Telescope or the TESS satellite, Transiting Exoplanet Survey Satellite, has actually seen anything around the stars here. But, when Kepler was looking for planets around stars like this, it had to go to the individual star. It had to go to each star at a time and say, hey, is there anything around this one? Is there anything around this one? All right? And that's what happened with the Kepler Space Telescope. It was like a laser. It had to look at this one, then would look at these over here, individually. You couldn't see more than one. Then the transiting exoplanet survey satellite comes around, and it's got like a 25 by 90 degree field, and it's looking in that swath all the way up and down all at once and looking at all the stars at the same time. You know, and looking for transits. So that, I think, is pretty cool. Hey, Papa Tom.
That's a big strike up. Yeah, indeed.
Yeah.
Yes, Papa Tom is in the house.
It's a huge swath. Okay, let's go see what else we may want to see here. I did threaten to go see the Santa sleigh cluster, didn't I?
I think you did.
Only because it's just weirdly on my mind, and I don't know why.
You're looking forward to Christmas?
No.
It's those cookies, right?
No. No way. No more Christmas cookies.
Yeah.
I don't have the stomach for them anymore. I'm so I don't know. Once you start exercising, you know, I exercise every day, and once you start dropping some pounds that you've had, you know, weighing you down, you begin to think about, you know, the things you actually eat and consume.
Yeah.
And I mean, an Italian lemon cookie with that white frosting. Oh yeah. Okay. You cannot make me turn away from those. There's no doubt.
Yeah, well, the thing, this water diet thing, it's like sweets have absolutely no appeal for me at all.
Yeah.
Yeah, it's crazy.
So, you're doing this water thing because I was doing the water thing?
Well, I kind of found out about it, and I sort of went, I think I can do that.
Yeah.
Yeah, and I've lost track of at one point I was sort of counting the days, thinking, you know, okay, I can stick onto it, you know, for like 2 weeks, 3, but like I've lost track of when. It just, it's just a way of life.
Mm-hmm. I mean, I just drink water all day. You know what, though? I've figured out a way to keep the same weight and actually eat a breakfast. You know,
oh, really?
You just eat sensibly, yeah.
Yeah.
Yep. Okay.
And I sort of don't want to break that stride, so I'm just gonna stick to the dinner part. You know, yeah.
And I've been doing that too, and tonight actually I didn't have any dinner. I just decided I was gonna come down and do this for you guys. I wasn't gonna eat.
Right, me too.
I didn't eat. You know. Well, I'm sorry you didn't eat.
Oh no! Hey, it's like it's so strange because the psychological impact is greater than the physiological, and it's you know, you just give yourself a little talking to. But the desire to eat has also lessened, dropped way away.
Yeah. Yeah, and now like you can put junk food in front of me and I won't want to eat it. And I've always been a terrible glutton for junk food. Oh. You know, I have sugar headaches. Eat so much sugar.
Oh my gosh! Wow,
I've eaten the frosting off 5 cupcakes. What's wrong with me? I have a sugar headache.
How did this happen?
Yeah. D. Smith. Now you understand how we keep coming back to the food topic. Tell me. I'm all ears. Well, I'm all headphones, but I'm the ears working there. Almost time for breakfast for me now. Tara says, well, it's 1 a.m. 1 a.m? Oh gosh.
What? Where does the time go?
It's 1 a.m. Yeah. Okay. Let's see if I can make this the last object. I may not, because it's mark one more, D'Antonio.
That's right. Yeah.
Just one more. Just one more.
Perfect music.
I'm not sure for what.
Oh, talking about food and breakfast, it sounds like a commercial jingle.
It does, doesn't it? Yeah. Start your day right, you have some toast.
That's it. You got it.
Have a bagel. Throw in the cream cheese. Hey, where's those English muffins, Frank? Hey, they're right here. Thomas's English muffins.
With peanut butter.
Take the peanut butter, throw it on a toast, and go to town.
Oh, that's it. That's absolutely
Silly.
it. Yep.
Okay.
Oh, Papa Tom says he's been watching you all day on the Discovery Channel.
Really? What am I doing all day in the Discovery Channel? What did you see, actually? Because, did they do a marathon of some sort?
A Mark D'Antonio marathon. Hey.
Well, it wouldn't be that, but what was... I had someone else say that they were seeing me today on the show. I don't know what show it was. Tell me what show you were watching, Tom. Be interested to know. I got another query for another show, actually, that wants me to do some serious work for them, too.
Oh, really?
Yeah. Of course, I can't talk about it because, of course, that's part of the deal, right?
Non-disclosure, right?
Yeah, actually, the NDA, yeah. Oh, What on Earth? Is that what you're saying? Was it the What on Earth show? I've done a lot of those episodes, so maybe that's what it was. Yeah. Now, my son graduated film school with a degree in journalism and film production. Yeah, What on Earth? Okay, cool. Very nice. Great show. They would never like make me say something I didn't want to say. They learned early on they can't script me because I'm not going to say something that isn't true. But I understand the how ratings work, and I was very happy to, talk about these objects that they're seeing, these anomalies, as like really interesting. Say, oh, well, what are those? Because they are all very interesting, So it was kind of fun to do that. This is a globular cluster we're looking at right here. And let me just see if I can get you data on this cluster. What is... It's I don't have a distance on it, but it's probably going to be well over 20,000 light years away, maybe more. And it might have maybe 40, 50,000 stars in it. It's really beautiful. It's really beautiful, but there's also... I have to see one more thing because I'm seeing something odd here. Yeah. See this star here? You see that little glow?
Right.
Okay, if I zoom in and I move this around, see that glow's moving with it. That's
really?
That's a strange little glow that's going on there, and I'm not sure what that is. So what I'm going to do is I'm going to look to see if there's anything. Oh, then there is. Look at that.
I'll be darned.
This wasn't showing up. And let's make sure that it's in the same field. Oh, yes, it is. Look at that. This is the field of the telescope. And if we put the globular cluster up at the upper right-hand corner of this right here, then we should see this faint planetary nebula down to the lower left, right? Let's go see.
Very faint.
Yeah, so we put it up here. Okay, and if it's up there, then here is the planetary. This frame should be a little smaller, by the way, because this was made for a wider field telescope. So the frame is really in here more. And there is this planetary. What is that planetary? Oh, that's IC 1295. That's Index Catalog 1295. And it says that this object is literally 3,372 light years away, but there it is. That's pretty good.
Wow.
You can see the color. You can actually see that
Yeah.
has a color to it.
My eyes have gotten so much better on seeing what you're talking about.
I'm
It's
glad.
like it's a learned thing.
It is.
Yeah.
Okay. I'm going to go and try to do a 1-minute exposure here and see if we can pick up any more detail.
And I'm going to say hi to Papa Tom. Hi.
Oh,
Again.
that's okay, Tom. Alrighty, so now, see, it's funny because I didn't know this was there, because when I looked at the object like this, we're zoomed out a little bit, and you get out to a certain point, and you know, this didn't show up. It didn't have a green dot in there. See?
Yeah.
But then you get closer, and this green dot shows up, and it's like, oh. Now the green dot is just a symbol to indicate where it is. It's not green because it's really green, although it is somewhat green. Ish. Yeah, so that's kind of cool.
Wow.
We see this faint globular cluster and a planetary nebula. And when I look at these planetary nebulae, okay, oh, that's even better. Look at that.
Whoa, Nelly.
You can see the this structure. You can see this.
Definitely, yeah.
Oxygen 3, and you got this this. I don't know what you call it. I mean, it's like a halo of reddish neon or hydrogen alpha. Beautiful. Actually, maybe it's this round thing right there. See?
Yep. Oh my gosh, even a little. Wow, look at that.
Yeah.
Wow.
And you can see that it's got sort of a area inside where you're seeing less, and it might be a spherical object that we're looking at. Okay. Now here's how that works. Okay, when you have one of these nebulae, a star is going to expand and puff off these shells of material in its life. As it's getting older, these shells will puff out. Okay, from the edge, you can't see through my fingers, but when it's like this, you can see through my fingers. Okay, because you're seeing through less material. Here on the edge, you're seeing through more material. So when you look at this planetary nebula, what you're seeing, I think, is on the edges, it's like this. But then when it gets to the front or the back, okay, when it gets to the front or the back, you're seeing through less material. So it's semi-transparent, which explains why we see a center area that's darker than the outside area. Because the outside area is this area here where you can't see through the fingers, right? The gas in this
Right,
spherical,
I'm getting it. Yeah.
Okay. Here in the front and the back, it's thinner, okay? And it looks thicker on the edges. I think that's how that works. I mean, in my view, that's how some of these planetaries work. And I think it's really neat. So from that, what that means is from any direction you look at this nebula from in the universe, any direction, anywhere, you're going to see the same shape. It's going to kind of have that area in the center that's a little bit darker, kind of like a ring nebula might look like in the middle. It's like, see how it's more dark in the center? Yeah. And I think that's it. We caught a very faint planetary nebula tonight, guys. Very cool.
Very cool.
Yes, indeed. Very nice indeed. Let's see if we've got anything else that we want to look at right now. Of course, there's plenty we want to look at, but the summer Milky Way is going away. Yeah. And see if I can get to Jupiter. I'm not sure I can even get to Jupiter right now. The dome might still be in the way. If it is, then we'll save Jupiter for another night. Okay, so we get to a star. Alright, well, that star is actually there. We're going to go racing this way to see. The star's going to go that way because we're going to head to Jupiter. Okay. Hey, we did it. Not bad.
What do you know? What do you know?
Yeah. And
gorgeous.
Yeah, and let's zoom in on that here because I want to see the layout of the moons. Okay.
Oh wow.
Yep. So we can't see. Okay, so what happened? Where'd you go? Where's it moving to?
What?
Oh, it did something really bad. I didn't like that. I didn't ask for that. Why did it do that? Very, very odd. Where does it think it's going? You see that? We had Jupiter in there. And all of a sudden
Right. And then
it takes off. Well, you know what? You get your sorry behind back to where I told you to go. All right? And I'm going to just do that right now. All right. Let's do this. Let's get its sorry behind back to where it belongs.
yeah, Tara says, "Hello, Jupiter. Goodbye, Jupiter."
That's right. Hello, Jupiter. Goodbye. Yeah, exactly. All right. Well, we're going to do this. And we're going to bring it back in. Okay. Don't ever do that again or you're going to go to your room. Jupiter. Jupiter, you're acting stupider. Cut it out. Okay.
Oh, ouch. That's wonderful.
No, it isn't. It was very bad.
Yeah.
It is very
If it
bad.
when it Go ahead.
Very bad.
I just
Okay.
thought it was great.
So this outer one is Callisto, and then the inner one is Io. And Europa is actually behind Jupiter right now. And then out here is going to be Ganymede. Okay? And so this is Ganymede. Europa's behind the planet right now and will probably reemerge at some point. I'm not sure when. And then this is Io. And this is Callisto. And in order of distance, it's Io, followed by Europa, followed by Ganymede, and then Callisto in terms of actual distance from Jupiter. And that's what we're looking at here, the moons, okay? That's a star out there. That's not a moon running away. Okay, and now what we'll do is, so, see, this is the part that is hard because in order to show you the planet's cloud bands, we actually have to drop down the exposure so that it's very, very low, a short exposure. But when we do that, and we bring this, this is 50 ISO. We're bringing it down to the lowest level we can. And now, if you notice, as I drop these down, I'm at 0.8 seconds, and the moons are only just barely visible. I have to keep going so we start to see the cloud bands on Jupiter. So a fifth of a second. So now if I take that picture, and then we'll see the image right away. Let's see what it looks like. We can see cloud bands on Jupiter, but
Yeah.
we're looking through some high clouds, so it's a little bit tough right now. But, you know, I can do my focus thing, and that's what I'll do. I'm going to increase the exposure until I start to see a moon. There we go. And then we're going to say, bring me my focus. Mr. Smoker, bring me my focus. And I will just drop it down. Okay, that was too fast. All right, I will come back up.
Are we able to see the red spot?
Only if it's facing us at the moment.
Okay.
So we have to go see. All right, so let's go. I gotta take us over just a little more. Where'd it go? Oh. Okay, hold on one second. Let me bring in the moon. There we go. Okay. Now I'm going to focus. It might be very well focused, but it may not. That looked like it actually got a little better. So let's take us way out, wildly out. Grab it, bring it wildly down, and then do the fine motions here. Okay, that might actually be pretty well focused. So what we're going to do now is we're going to go back down. Let's try this. This is 1/8 of a second. Oh yeah, that's better.
Ooh.
Yeah. And now when we zoom in, we can see multiple cloud bands on Jupiter. Quite nice. And where's the great red spot? Well, let's see if it's actually facing us right now. It may not be. Maybe on the other side of the planet. Yeah, and it is. See? It's not here.
Yeah.
It's going to be elsewhere. Yep. Pretty amazing. Now what you can do with these is we can actually reduce this to 1/10 of a second, and we can see the point where we can actually see a little more data. You know, this is looking a little better. We're seeing the biggest planet in our solar system here. Very nice.
Mm.
Yep. And let's go down to a 15th. Okay. Not bad. Well, this has been a good night, folks. I want to thank you for coming out. I'm gonna call it a night. I'm getting tired. I still have to go and put things away. But you know what I'm gonna do? I'm gonna show you that sequence. Okay, I'm gonna show you that right now. Okay, so I am going to. Yes, hold on. Got to get rid of this.
Yeah, there we are.
Okay, hang on.
Yeah.
No, not that one. I think I might have gypped you guys out of seeing something.
You know, I thought maybe it was just my screen, but then I realized I'm sharing your screen. So yeah, we could just see a little edge over in the right of the frame, right?
My mistake. I'm sorry about that. So what I'll do is I'm going to bring that camera back, and I'm going to bring this up, and I'm going to take this picture again so you can see what I was talking about. Okay. So there.
Yeah,
we go.
D. Smith says that we didn't see it. Yeah, and Tara also says we didn't see anything. It was all black. Yeah. Okay.
Yeah,
Well.
Okay.
It's a fix on its way.
Yeah. So there we are. Now you can see the moons. What you were supposed to see before. I'm sorry, Jupiter. You can see the cloud bands here.
Yeah.
So you never actually. Okay. So you know what I can do? I got to go back and redo these shots I did before so you can see them. Slightly longer exposure. Just go to 10th. Take that, and the planet's disk will be a little brighter. Okay, and you can see now the colors of Jupiter. You know what's interesting? Jupiter is mostly hydrogen gas, and this part here, this is like ammonium hydrosulfide. It's like a tiny little impurity, fraction of a percent in the atmosphere, but it's more than enough to make it look like this. That's one of the things. There's several other impurities in the Jovian atmosphere as well. But if I can just go a little brighter here. Okay, so this is 3.2 seconds. Let's take a picture of that. Why, you may say? Well, because I want to just check to see when Europa might be coming out.
Oh.
Yeah, and I don't think Europa's behind Jupiter right now. So it's not visible. It looks like it just went behind Jupiter. It's probably another 45, 50 minutes before it comes out. So.
And Tara says, thanks for doing one more for us, Mark. So say we all.
Well, you know what? I forgot that I had the focus rectangle up. I apologize. Yeah. So, yes.
Cypher 2 says, yes, Mark delivers. Oh, indeed.
Hey, Cypher 2. I didn't see you. You must have been lurking tonight. Thanks for coming. Yeah, so let's just try this one more time. Just do one more. I'll try 1/5 of a second again. Yeah, the night isn't very still, you know, but you know what? Not that bad. I can tell you we had some good times tonight.
We did indeed.
Okay, now I can say I can show you the closeout and take care of that. All right, so first things first, we're going to disconnect the telescope from. Let me get this guy up here. All right, we disconnect the telescope from the stellarium. All right, and then we get out. And now we're disconnected. All right, you see that we no longer have our scope icon showing where our scope is. Okay. Then we go to, let's see, now we go to our, I think this is probably the best one to look at. And let me see if I gotta see if our telescope, okay. Now we can bring up the, we're going to go into the remote live view again. And we're going to bring up our telescope view. Here's our view into the dome. And I'll show you that. Kind of cool.
Love that.
Okay. This you're seeing right here, this is our automatic cover for the telescope. I wrote a circuit and put in some hardware to actually close the cover on the telescope. That's the slot of the dome. All right. So what I'm going to do now is, now that you can see that, I will do this. I'm going to first, now you can't see that. Look at that. Okay.
Right.
What the heck? What did I do? I must have gone away. I'm so good at this. All right. Jeez. Okay, hold on a second.
Come on.
Yeah, no, let me bring it back. Okay. All right. So now, what I want to show you is that we can do a couple things here. Okay, and why is it doing that? 1 second. Okay. Yeah, and let's just see what's going on. I was hoping to show you something here. Ay. Okay. All right. So now if we come back to our telescope here, all right. This here is my program I wrote to run the observatory. But what I'm going to do now is, if I was in Arizona, this is where I would actually turn off the power to the telescope. But I can't do it yet until I take the telescope and park it. And what does that mean? Well, when I hit park over here, all right, and I say yes, the telescope will now make a final maneuver to bring itself into a parked position where it will stop for the evening. And I'm just going to refresh this because it doesn't look like it's done it. Okay, well that's no fun. It's not doing anything. Sure, it disconnected. Yeah, welcome to Live Telescopes.
You know.
That's okay. I've been having some not Wi-Fi issues because the telescope doesn't run on Wi-Fi. Okay, well, I guess I'm not going to be able to show you as I wanted to. I don't know why it's doing that. But anyway, okay, first things first, I parked the telescope. Yes, it's parked now. And then what I can do is, once it's parked, then what I do is I shut off the power to the pier, which I did. Which I did not actually. I'm going to turn off the power now that it's parked. So here I park it and I shut off the power. Now it says the pier is off, and it is. The power is off. Okay. And then what I can do here is, now what I do, now that it's parked, it means that the telescope is out of the way should the roof close and strike the telescope. So now I just say close the roof, and the roof is now closing, although you can't see that because this is for the Arizona Observatory. That sliding garage roof was going to close horizontally.
Right.
And then what I do is I will actually now it's time to actually close or actually shut the cover, and that is this next thing that I do. And right now the telescope cover is closing.
David Schmidt sums it up, Mark. He says, to paraphrase that old fishing aphorism, a bad night sky watching with Mark is better than a good day working. And he really appreciates the generosity and the time, as do we all.
Well, David, thank you. That's very kind. All right, so the telescope is now closed down, and I can this program here is sort of a operational system that I wrote to take care of any problems that might occur. Because you can get problems occurring if you're not careful. And so now, having done this, I'm really pleased to see that it works like it's supposed to. And this is the observatory. So I'll see the observatory screen no matter what, wherever I am.
Mm-hmm.
All right. And so then we're done. And that's all there is to it, folks. And now we are done for the evening. When I get the system operational in terms of the camera working better, then you'll actually see all this stuff happening. I like to show you what's happening. The power-up system is actually just as cool, but unfortunately, I really need to pay very close attention to what's going on during power-up and not make any mistakes. It's kind of idiot-proof, so even I can do it. But I still try. I still try to be careful because I'm also thinking in terms of other people that are going to be using this telescope. I mean, yes, SkyTour LiveStream is my telescope. Yes, I get it. But it doesn't mean that, someone who demonstrates a capability to operate it might not actually operate it for a night. To do some research and do some photography and take some things for themselves. But most of it is actually for all of you. So, that said, I want to thank you guys once again for coming out here. I really enjoyed your company tonight. And Carol, thank you for joining me.
Oh, wouldn't rather be doing anything else.
Well, I appreciate that so much. And don't forget, if you're interested in the book, The Populated Universe, it's on Amazon worldwide. And you can get it in 3 formats, different sizes, in color or black and white. E-read and ebook, black and white 6x9 and 8.5x11 full color. And it's around 370 pages in its biggest format, and it's over 400 in the smaller. But you're gonna be hopefully treated to a journey through space and time, and looking at planets around other stars, and learn about the prospects of life in the universe, how it happened here, and why we think it can happen elsewhere. It's all just a wonderful, and I'm not trying to say, look at me, look what I did, and pat myself on the back. I'm saying it's, and when I say wonderful, it's like, it's needed, okay, because it bridges the gap between the complex and the simpler way of explaining things, and still gives you exactly what you need to know.
Absolutely.
And Carol is going to be responsible, I think, for the 4th version of the book. And
hold me back.
Yeah.
Oh yes, indeed, and just loving every minute of that.
You can hear her voice. It's very melodic and engaging, and so imagine her reading the book in an audiobook. It's really beautiful, and I said before at the beginning, she emphasizes all the right words at the right time. It's like it's scary, actually, because it feels,
oh my God.
feels like she kind of like wrote the book. Yeah.
Once again, I just want to emphasize there, your words and your spirit comes through just so incredibly, and the accessibility is off the charts.
Well,
and also, yeah, just listening to you so much, I've got your humor, I've got your rhythm, I think, if I may be so bold, and it's an honor that I cannot even express.
Well, you humble me. I'm just happy that you're willing to do it. And I also have to thank Tara, who's in the chat here tonight. She was actually the person who went through every single page and edited that book to get rid of all of my little foibles and silliness that I messed up. So
and what an enterprise that was. Wow.
It was a long process, but you know what? I got a document from her, and I was like, whoa, she really read this thing.
Yeah.
Errors here and there, spelling errors mostly, and then there were some punctuation errors. But I gotta tell you, I wrote the book. Before my vision had fully returned. I mean, I finished the book before my vision had fully returned, because after having surgery that went sideways, right, and I was a blind quadriplegic for a period of time, and working my way back from that was a long process, and I used finishing the book as therapy, and I used building the SkyTour LiveStream Observatory out here as therapy. So the fact that I got it pointing in the right direction is a miracle.
Yeah, I was going to say that's some therapy, because it really worked miraculously.
Well, mostly it's because I am part of a rebel alliance and a traitor. That's my Darth Vader glass.
Oh, that's it. I forgot that part.
That's the Vader glass. Yeah, so, no, but really, honestly, Tara edited the book and got rid of all my silly spelling mistakes. And many of them I made in finishing the book, because I really couldn't quite see yet, because I had to teach my brain how to see again, teach myself how to walk again. Neuroscience doesn't understand, and I think that I do, because I went through it. I taught other people, and I actually helped other people, including Daryl, who's already gone, but tonight. But if you understand how your body works and how it reacts to pain, you'll learn to embrace the pain in order to heal, and that's what I did. Embracing the pain is the most important thing. But enough on that. There's no more astronomical things on the screen, so it's boring.
Never
Oh,
boring.
yeah, well, thank you, but it is. You guys, you have a good night, and if you have any questions, remember you can always reach me at SkyTour Radio at kgraradio.com, and you can always ask questions there if you like, but I'll be happy to answer them on our next stream. And if it's clear tomorrow night, well, I'll see you tomorrow night. See, I don't shirk my responsibilities. So anyway, guys.
Yeah. And you share your passion, and we all benefit.
I love what I do. I love what I do. You know, I love what I do, and I do what I love. You know, and that's
Yeah.
right, it's astronomy. You know, it's the study of the universe. It's the study of where we come from. So you guys have a good night. And on behalf of Daryl, who's already left, and I'm sure Carol, you would say the same thing. Thank you for coming, and we'll see you on the next stream. All right. So good night, everybody.
Good night.